all over Bangkok. All right, never been. I'm excited to go sometime. So quick, I think we're pretty much done with the housekeeping. Antje is going to continue giving people IP addresses. Also, Antje has a way to get a hold of me kind of behind the scenes in case of all disaster. So the title of this workshop is End-to-End ML Pipelines. We're going to be covering TensorFlow Extended, KubeFlow, Airflow, and actually just last night I threw in a project by my old company Databricks called MLflow. And what we're seeing here is a bit of a Frankenstein type of pipeline architecture, and the sort of pipeline. There's about 4 different standards happening all at the same time, and having been in this field quite a bit, I've used all of them in different capacities. So my goal here is to actually show you guys kind of clear swim lanes through each of these 3 or 4 projects. They're all part of pipeline. They're all part of your instance. They're all part of the open source. You can pull all this stuff down, play with it afterward. You can set up your own instance inside of your own cloud. But what we're going to do here today is we've got about 15 or 20 notebooks that we're going to go through, and these notebooks aren't just Python code. We're also going to be spawning like Kubernetes pods and doing hyperparameter tuning and all sorts of fun stuff. So I think we're covering pretty much all the major aspects of a modern ML pipeline, and doing it in the context of these more recent projects. So in case you don't know, my name is Chris Fregley, founded this company Pipeline AI a couple of years ago. Let me try to advance here. At Pipeline, we're focused on real-time machine learning. It is really our sweet spot. Of course, all of our customers want more than just the sort of real-time machine learning and pushing models into production. And what they want is control over the model training as well, and then reproducibility. So that's been our focus for the end of last year, and then all of this year is more training. We kind of started opposite of most machine learning companies, where most folks start with training and then work and then just kind of deal with models in production as an afterthought. We actually went the other way. We started kind of at the end of the pipeline, or sort of making the production deployments and the experimentation, online experimentation. And then now we've backed into more of the batch. So I came from Databricks. So this is the actual old school, this is the original Databricks logo. This is the one that's on a lot of my hoodies and t-shirts. And so, of course, very familiar with Spark, contributor Spark, did a lot of early Spark work with lots of big companies in the Bay Area and across the world. Also, before that, I was at Netflix. Also did a stint, it didn't fit on the slide here, with the IBM Spark Technology Center. So I helped found that after Databricks. IBM wanted to be known as the Spark people, and so I was able to build up a team of folks at IBM, where we then we had brought in four committers as well too from the Spark community into IBM. So yeah, that was really fun. But before that was Netflix, and did a couple of years there when I first moved to the Bay Area from Chicago. And I was doing a lot of machine learning, pushing models into production. We actually were part of the original streaming team for Netflix, so this was really exciting. We moved Netflix over to the cloud. We also supported the iPhone and Android devices, all the thousands of streaming devices that you can imagine, even the laptops, right? The old Silverlight stuff is what we called it back then. So a lot of very high scale sort of microservice experience, and that combined with my Databricks experience and machine learning really led to what has become Pipeline AI. I have this O'Reilly series on Safari that you can find, and it's called High Performance TensorFlow in Production. We're actually re-upping that this year sometime, and will likely include a lot of this KubeFlow stuff. So keep an eye out for that. You have to be a Safari member to gain access to it, but it's a couple $100 a year, and you get access to all the conferences and all the good stuff. Also, I have this meetup, and it's based here in San Francisco, but we actually have chapters all over the world. So join one near you, or join the mothership, which is here in San Francisco. I would join the mothership as well as the one near you, because we do tend to post all the links and videos to the San Francisco one, because we know that that's the more global version there. So here's the link for that. We're starting to approach about 12,000 members, so pretty excited. We were actually the first TensorFlow meetup shortly after TensorFlow was released. Read the white paper and decided to rebrand the meetup as Spark and TensorFlow. So really, these are two technologies that we see quite a bit. So of course, everyone has Spark these days. So anyone with any sort of processing beyond a single laptop is using Spark. And then TensorFlow, we're starting to see lots of integrations between those two. Also, the folks at Databricks have been starting to explore TensorFlow more and more, and I know they've been doing some hiring along those lines. We do have Community Edition. You don't have to use this today. This is just for the future. Today, you are going to use the IP address that we've sent you. So like beyond today, you could check out community.pipeline. This is basically an instance of our Enterprise Edition, some things disabled, but you can try it and play with it at your own leisure. Okay, so I think we already covered this in the poll, but you don't really need to know too much about linear algebra, things like that, but of course, familiarity with these concepts will help. And the state of affairs today with KubeFlow and TFX is you actually still do need to know a little bit about systems. It's still not the kind of one button, press and then things all just kind of magically happen. You actually still have to know a little bit about Docker and how it works. You have to know base Docker images. We're constantly specifying base Docker images to make sure that we have all the dependencies. Things are getting a little bit better where we can now do analysis on the Python job that's running and look at the requirements, and we can automatically generate the requirements TXT and Conda YAML, and I'll show that here in a bit throughout the day. Hopefully you're familiar with Jupyter Notebooks. These are pretty ubiquitous these days for more ad hoc, and hopefully you know how to get around there. I'll show it. So the way that we'll be running the actual exercises and hands-on is I'm going to give you guys 15, 20 minutes to do them on your own, and then we'll circle back and then do them all together. So and of course keeping an eye on questions and such along the way. Okay, I've got 10 notes specific to this workshop and to the hands-on that you guys should know about. So please pay attention to this part. This is very important. This is all very much greenfield, pre-release type of stuff. KubeFlow is only on 0.5. Probably the most stable is the MLflow stuff, which is at like 1.0. Now with MLflow, that's actually the sort of least powerful of the projects that we'll be discussing today. So with stability or with features comes instability. So you will almost certainly see these types of warnings happening, and these will show up in your browser within the Jupyter Notebook. My point here is hold off on reporting these. These are well known. The notebooks will all work okay, I promise. There's a couple cases where we have to refresh the browser, potentially kill the Jupyter kernel, potentially shut down all notebooks until so that we can run a pretty heavy notebook. But we'll do all this stuff together. Don't worry. But just know, you will see errors, and we're all a little bit OCD in this field. I know I'm OCD as well, These drive me crazy, but there's not much we can do except either suppress them in a future version of this workshop. But I do want you guys to see all of the things that can happen and not, hide things from you. So things will be okay. And let's see. So note number 2, a lot of material. I've given you guys free reign. You have your own instance. If you want to rm-rf root and kill the instance, that's fine. I would recommend not doing that. But my point here is there are lots of places you can explore on your own. You can even pull down your own notebooks. You can pull down Bitcoin, like mining, clients. I don't care. These will be shut down today at 4:30. So do with them what you want. I do warn, though, if you start to install too many things, it might create instability with the rest of the hands-on materials. And unfortunately, with so many people, it's going to be difficult to diagnose every single one-off that gets introduced that way. So we know that the current flow works, and if you start to kind of ski off the main path and go backcountry skiing through the trees, might actually cause instability. Now, we do have a couple extra instances. If you do end up killing your instance somehow, we can quickly give you another one, but we only have a few of those because of cloud quotas that we just hit. This is the specs of your instance. You can thank me later, or you can thank me right now. 16 CPUs, 104 gigs of RAM, 200 gig hard drive, solid state. We wanted to give you guys beefy machines. There's a lot of exploration here, and there's some pretty heavy analysis that we'll be doing. We're not only dealing with just MNIST and small data sets. We're also dealing with some pretty real world data sets. So we wanted to give you guys pretty beefy machines and not skimp in this area. We would rather pay a little bit extra so that you guys have a good experience than save a few dollars and then be dealing with like out of memory or like type issues. Also, as a little surprise for this being the inaugural version of this, we've got access. We've given you guys access from your instance to a TPU v3 cluster. This is the newer cluster. This is the one that's like $9 per hour or whatever. And you have access. We have notebooks on it. Hold tight. We'll play with these in a bit. And yes, I have to say these things are smoking fast. The fact that we are using TPUs means that we are using Google Cloud today. That is more of a convenience thing to get access to these TPUs. You can run these, the same workshop on Azure or on Amazon. Quick note about the data sets. We'll be using the Chicago taxi data set. This is kind of the reference data set used by TFX. I stuck with this because there was a lot of examples and actually quite a bit of support from, there's a whole bunch of GitHub issues that are like related to these samples. Because TFX and KubeFlow are still a bit greenfield, if I tried to stray into a different data set, I was hitting a lot of issues. So just know that today's stuff is a pretty decent sized Chicago taxi data set. I'll explain what this is here in a bit. Some of the features are in the upper right there. That's an actual Chicago taxi from near where I used to live, and a quick plug for my Chicago Cubs baseball team. We'll also be using the Fashion MNIST data set. We'll be using, the typical wine like data set for some of the MLflow examples and a few other smaller ones. But for like most part, it'll be the Chicago taxi data set. Some of these notebooks take on the order of minutes to complete, not seconds like you might be used to. Please be patient. We are using larger data sets, and we're doing quite a bit of browser magic here. I think that's maybe, oh, yeah. So let me back up here a sec. So these notebooks do take some time, and we've got tricks and tips on if the notebook does get stuck. We've seen a tiny bit of instability with Jupyter, especially when there's a lot of browser voodoo happening. Means that there's WebSockets being opened and timing out here and there. So ways will help you get around it. We'll like tell you how to refresh the browser, or like tell you when to refresh the browser, when you should close the kernel, when you should shut down the notebooks before. So just bear with us. Yeah, any questions? This is Antya. She'll be helping out. She's our little clippy for today. Also, just to manage expectations, KubeFlow is still not a silver bullet. So this is standard disclaimer. I'm not going to spend too much time here, but just know that there's still gaps, and these gaps are getting smaller in the modern pipeline. And know that there's quite a bit of voodoo. You'll hear me use that term. And the goal of this workshop is to point out where this voodoo lives and how to track down the voodoo. So that's a lot of what we'll be exploring here in these notebooks. This workshop's not cloud dependent. There are 2 small exceptions, which we do have patches underway. So while we had planned on making this 100% portable, there's still 2 small places specific to the examples that we're using, which is the taxi data set that do require that you have one is that you have a dependency on Google Cloud Storage. The second one is that we have a dependency on the Google Cloud Registry, which is their Docker registry. But these are pretty easy to overcome. We're actually waiting for patches from the KubeFlow and TFX community. Should be coming shortly. There's open issues out there. So this next release. So the KubeFlow community just announced an on-premise working group, and I'm part of those calls every week. So, things like using Minio instead of, like calling into S3 directly. Minio is this nice layer on top of S3 and, Google Cloud, and kind of gives you one common interface. But where possible, we're using straight up Kubernetes. So really the only dependency here is Kubernetes right now. There's except for these 2 small exceptions, there's no dependency on a specific cloud. So one thing I discovered after creating the title and the agenda for this workshop was once I got into the deep bowels and some of the more advanced features of TFX and KubeFlow, I realized that TensorFlow2 is not fully supported. There's still a few things that would have just spun this workshop out of control in terms of preparation if I stuck to only TensorFlow 2.0. So to compromise, I have a small section on TensorFlow 2.0 and some of the newer features that'll come, I think, later this afternoon. So yeah, hold tight on that. And I apologize for this whole thing not being too compatible. Since 2.0 still is not fully out yet. It was just released in beta last week, and it was in alpha maybe about a month before that. There's still some gaps in some of the examples. So I mentioned this already, but what you want to do is shut down every notebook after you've run it. So we'll run the notebook, we'll take a look at it, we'll discuss it. Before moving on to the next notebook, I highly recommend that you click the shutdown. Not just kill the kernel or restart the kernel, but actually shut it down. This has less to do with the resources because we have plenty of VM resources here. We have 16 cores and 100 gigs of RAM. It's more the stability of Jupyter, and because we are doing a lot of crazy stuff within Jupyter for this workshop, it's just best that this last couple weeks of testing, the best way that we found to stabilize it is to shut down. I was just told before the workshop that incognito mode doesn't really help that much. I cleared my entire cache the other day and it seemed to work really well, and the notebooks got better. I certainly don't want you guys to mess with your browser cache. That violates everything that I'm for. But if you are having stability problems with these Jupyter notebooks, you might want to try incognito mode and just hopefully, at least I think that should clear the cache for that particular session. So why TFX and why KubeFlow? So the higher level concept here is any machine learning pipeline has, between 6 and, I would say maybe even 12 different systems at play here. I would say double this amount, but this is a, pretty straightforward diagram, small diagram here. These are all the different components. We'll be taking a look at data analysis, data transformation, data validation. Splitting data is more on, kind of divvying up batches of data to then pass into training. We'll be building models. We'll be validating the model. We'll be doing distributed training with TensorFlow on the Kubernetes cluster. We'll be then rolling out models and then serving them. And of course, cross-cutting all this is System 6 here, which is more of configuration monitoring logging. So the main goal here is this first bullet point, which is training and model serving. So when I'm training the model, and then when I go to actually put the model into production, these are fundamentally dealing with different data. So training data is batch, it's historical, it's data from today and from like today till 5 years ago. When the second that we put the model in production, it's dealing with data that's happening right now. And oftentimes, and I'm sure we've all seen this to like different degrees, there's skew that happens when the second that we push a fraud model into production, for example, that model could get defrauded right away. And so how do you deal with this? Well, we need to be able to first detect this. And so some of the ways that we'll be detecting and sort of calculating distributions of data during training time, we can also use to kind of keep an eye on that data that's coming in during serving time, or like during prediction time. So that to me is the biggest benefit. Now, if you've just played with like machine learning and kind of poked around a little bit, you certainly have not seen this issue. So it might be hard for some of you to understand, but people that have been practicing machine learning for a while, this is a real problem. So the problem is that we train on historical data, but we're pushing the model into live data. And so how do we put some type of structure around there and then be able to capture just certain discrepancies with that data. So improving consistency between those phases. Let's see. The ability to sort of manage pipeline complexity. I would argue right now TFX and KubeFlow actually increase complexity because there is so much voodoo happening and there's a lot of pointers to Docker images that you don't quite know where they came from, but they work somehow, or things just kind of pop out of nowhere with these systems. So very much still a very complex. This goes back to my comment that KubeFlow is not a silver bullet, but is definitely in the right direction. The idea, of course, is to improve portability of these pipelines, and some other nice things. We can wrangle large data sets. We can analyze these data sets. We can normalize features maybe that were difficult to sort of wrangle in the past, or they were split across multiple systems. The goal, of course, is to improve model quality and also detect things early on if quality starts to degrade, for example, in the case of that fraudulent model or fraud model that is being defrauded the second that it goes into production. This other concept, composability, it's kind of a functional, fun computer science term, which is always nice to throw in. Makes us sound like we're doing something useful here. Okay, so this is the overall agenda. Setting up, we'll start off first by kind of setting up the environment. We have already actually set up Kubernetes. So what we'll be doing is just looking at the Kubernetes cluster that's living on your instance. So keep in mind that this is a single instance that you're using that has a Kubernetes cluster installed. And while it's single node, it can very easily be extended to be multiple nodes. And in fact, if we have time towards the end, we could actually join all of our instances into one big cluster and then run a training job. I don't know if we like really haven't tested that too much with this iteration of the workshop. We've done it in the past with Kubernetes. So we probably won't get to it today, but sort of conceptually, just know that your single node actually has a Kubernetes cluster on it that could be joined with other Kubernetes clusters or could participate as a node within a larger Kubernetes cluster. But for all purposes today, we have a single node, and just pretend like it's a multiple node cluster. It doesn't matter. It's running Kubernetes, and all of our work will be within that Kubernetes cluster. Also, we'll be talking about TFX, kind of demystify what this thing is. So again, TFX to me is actually the most important thing that's been coming out of Google recently. I've talked with multiple Google people so TFX was announced as a paper, and then later bits and pieces of it have started to come out. And I never quite understood where they were going with TFX, or if TFX was ever actually going to be released, or if TFX was even a product or a real thing within Google. And I've been told by like many people that TFX is the core of all Google machine learning, and that we're only seeing the tip of the iceberg when they release small pieces like the TensorFlow model analysis library or TensorFlow serving, which came out sort of day one with TensorFlow. These are all part of a larger ecosystem within Google called TensorFlow Extended. What we'll see here in a bit is KubeFlow is actually just an orchestrator for TensorFlow Extended. So TFX is the broader category, and we have Airflow, which we'll show, that is going to be using TFX components and participates in TFX. We'll also then show KubeFlow and how KubeFlow uses TFX. So while we all have heard about KubeFlow and are familiar with the sort of branding aspect of KubeFlow, really the true power, in like my opinion, is this sort of larger like ecosystem called TFX. So we'll dive deep into that here in a bit. We'll then cover pipelines with Airflow and KubeFlow in the context of TFX. We'll then do some cool hyperparameter tuning. This is one of the top things that people ask for. This actually wasn't in my poll for some reason. I should have put it in there, but I'm going to assume 80% of you are interested in hyperparameter tuning in some form or another. Maybe you don't call it that, but you want the ability to try out different parameters and different models even, right? So, and the sort of larger concept here is called AutoML, where you can sort of automatically figure out which frameworks you should use, which models, and which model parameters. And so we'll dive pretty deep into that here in a bit with some hands-on examples. Lastly, one of the things I'm super excited about, and I'm excited about this because this has been a like request from even back in my Databricks days, which is, okay, we have a notebook. We need to take this out of the notebook and put it onto a server. And so finally, there's this project within KubeFlow that's called Fairing, which we have a hands-on like notebook here for, that can take that notebook and deploy it onto Kubernetes with just like 1 or 2 commands. And it can actually inspect and figure out what is needed by that particular module that you're trying to deploy, that notebook, and can slurp it in and create a Docker image on the fly, and then push it out to the Docker registry, and then run that on the Kubernetes cluster. This is super powerful. This is super cool. And I should have updated the agenda here, but we're actually going to be using XGBoost for that. So yeah, I know there's lots of people that use XGBoost on a daily basis. So we'll be deploying the XGBoost notebook on Kubernetes directly. And then bonus. So this is for the inaugural folks here. We've got access to TPUs, so we'll be hands-on with that. I slipped in MLflow. This project just hit 1.0 last week, I think, or 2 weeks ago. So this is an experiment tracker that's really, more kind of geared towards the Spark community, Databricks community. It is fully open source though, so I do want to highlight it. I'm seeing MLflow creep into this Frankenstein system of, Airflow, KubeFlow, TFX. So I do want to highlight what's going on there. You could use it if you want. Maybe it's kind of a distraction. I'll leave it up to you guys to decide. Another project I've been working actively with recently with the Redis community is this new project that they released. They just announced it at the Redis conference a couple months ago. It's called Redis AI. And Redis AI, you can actually load in TensorFlow or PyTorch models into your Redis cluster and make predictions on that data that's in Redis. Now, Redis is like Memcache. It's a huge distributed cache. It's a common pattern, to load data into a cache so that you don't have to go back to the database every time. So really, this is like Redis's attempt to bring models and machine learning closer to where this data lives, which is in the Redis cluster. So we've got some examples of that I had prepared for the Redis conference a couple weeks ago, about 2 months ago. We'll also be talking about some TensorFlow2 stuff, specifically eager execution. We have examples of that. And the other one I want to slip in, something I'm very passionate about, is TensorFlow privacy libraries. So this is a separate library from TensorFlow core. And I think this is one of those that might not actually be TensorFlow2 compatible. So that was another reason why we had to stick with 1x. But some like really cool stuff here. So by TensorFlow privacy, what I mean there is we can train a model with privacy so that we don't necessarily have to go and mask the data that's coming in. TensorFlow can, during training, can actually do what's called differential privacy and can sort of introduce noise into the training data that we can, because we are familiar with it during training, we could subtract out that noise during predictions. So again, the more native these privacy concepts become to these frameworks, the much better off we are. So no matter what slips through, and then also if there's data that we have that we don't want to mask because that will actually destroy the power of the model, then we do want to keep that like original data intact and then just train it in a like private manner so that the output that data artifact called the TensorFlow model that we've trained now has privacy built into it. So some pretty cool stuff. Okay, I'm going to pause here and let me see, pause the share. There's a lot of chatter on the chat here, so I'm going to check in with Antya, make sure everything's cool. If you want to, take a look at this first. Oh, and I think you guys can't actually get to the notebooks until you get cloned. So let's see. Okay, let me just take a quick scan here. Okay, a lot of people just getting, will we get the slides and recordings? Yes, you will get everything. Okay, errors. If you see errors, you should definitely notify us. Warnings are okay. Preferred browser, we've tested everything in Chrome. Yeah, it looks like Auntie already got that. Okay. Yeah, Anirudh, I sent you email. Antia, can you get Anirudh a IP address? He is registered. Okay, looks like Antia already did.
Yes, I got that covered. So I think a couple of you people still have the hand icon raised. So I think I sent you all the IP address. You might just look through the chat window there with all the messages coming in. If you still have not seen it, keep the hand raised, or just better ping me a quick message here in the chat window. But all of you that I see, I sent you an IP address through the chat window here. For the folks who joined later, maybe, just ping me quickly here in the chat window.
Cool. Yes, once again, yeah, you have to be registered and send over an email to support@Pipeline. Okay, people are asking, is MLflow equivalent to KubeFlow? Think of MLflow as more of an experiment tracker. At least that's how we're going to show it. There's a couple parts to MLflow. We'll cover that later on today. So the MLflow is more part of a kind of bonus section that's going to happen later this afternoon. So I would say MLflow probably right now anyway is just a one piece of KubeFlow. So KubeFlow has experimentation tracking, and so does MLflow. But KubeFlow also has this slick sort of UI where you can visualize pipelines, similar to Airflow. Yes, Airflow has a way to visualize pipelines. And whereas MLflow is more right now, the power to me is it's an experiment tracker. So you can go and you can look at, so think of it like a place to post the results of your training runs. And that's exactly what the MLflow notebook will be later today. Let's see. Any PyTorch pointers? We don't have too much PyTorch in this particular workshop. And in fact, I think the Redis PyTorch example was broken as of last night. Let's see, the agenda, deploy the model to production with TensorFlow serving and Istio. I think we aren't actually going to do too much Istio today. We do have Istio in the cluster in Kubernetes, or sorry, on your instance, and it's actually powering some of the services. So if you want to, maybe during one of the breaks, maybe you could try some of the Istio stuff or TensorFlow serving examples. But that was one of the sections I decided to cut. So I've spoken about Istio for the last 2 years. There's plenty of material out there from Pipeline on Istio. It's just that today there was just a lot of other stuff to cover. Okay, people are asking about Azure. Azure does not have TPUs. Google Cloud is the only one with TPUs. We would normally be using GPUs, but I wanted to give you guys a special treat and give you access to the TPUs. You can get GPUs anywhere these days. Why use both Airflow and KubeFlow? I don't think you should use Airflow and KubeFlow. I would recommend picking one or the other. As far as I know, as far as I can understand, Airflow is actually better supported right now, especially with TFX, than KubeFlow. KubeFlow, still has a lot of kind of wonky things going on. The UI is still a little bit under construction. Whereas we know Airflow has been around forever, and we know Airflow works and has been used for many years, and most shops already know Airflow. So if I were to choose something today, and right now, I would stick with Airflow, and I would use TFX, and I'd follow the examples, and I would get my pipelines in and working with that. That's mostly because we already have Airflow set up. We know how Airflow works. Hopefully, I can give you guys more insight into the differences today, and then do they serve different purposes? They're at some point, I imagine KubeFlow will probably supersede Airflow. One big difference about Airflow is that you could do all of your pipelines within Python, and even a single Python file can actually represent this pretty complex pipeline. With KubeFlow, there's all these pointers to external Docker images, and you have outputs and inputs that you have to keep track of, and you have to store everything between all these components, and either using Minio or a distributed file system. So it's similar to what you're doing within Airflow actually, because there's always inputs and outputs for each component within Airflow. But yeah, I'm still I'm much more comfortable using Airflow in a production environment than I am KubeFlow right now. But that's just my own opinion. Will you share the installation instructions to install this? Yes. So, I know the URL of the Jupyter notebook, please. Okay. Yes, Antia, there's someone asking, I know the URL of the notebook.
Yes, so
any
I
guide?
did that. Yeah, Barbara, you can share how to get it set up here in a bit.
Okay.
I should have covered
And,
everyone with the IP addresses. If not, as said, just ping me quickly here on the chat window.
yeah, and I think we can close or lower all the hands, and then if people still need us, they could raise their hand or something there. Okay, someone's saying they don't have IP. Okay.
Yeah, I'll go back to you.
Notebook? Okay. Yeah, so Steph pointed out the GitHub. So the first thing that we need to do in our notebooks is to clone this GitHub repo. So I'm going to resume my share here. I'm going to bounce over to, let's see. We have to clone the notebooks. Okay. 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 Excuse us for 1 sec. We got some other people on our support channel that I want to get back to quickly. Okay, 1 more minute here. Okay. Okay. So I drained the support channel here. Let me go back and pull up my instance. I'm actually using a fresh instance just like you guys. So we'll hit any of the same issues at the same time. Okay, so give you guys, let me zoom in here. A quick rundown on what's happening here. Okay, don't forget Father's Day tomorrow. Okay, so on the left, we have obviously the home page, which is this kind of fun little dashboard here that has some quick shortcuts, some recent pipelines. These are actually sample pipelines. I'd say half of these work, some of them don't. We're going to introduce pipelines that do work, and pipeline runs and some quick start docs and things. This is Airflow, and while I'm in here, because I'm going to have to say this multiple times, everyone select this on right here. So we're toggling this on. This is something I didn't get a chance to script, so we have to all do it together. So for right now, just turn this on, and we'll get back to this in a bit. You can poke around here. If you want to trigger the DAG, go ahead, trigger the DAG. But I would actually just keep it like that for now. Okay, and then this is KubeFlow itself. Later on in, I think, the second or third or fifth or sixth notebook here, we'll be uploading a pipeline. These are sample ones. Again, some of these work, some of them don't. Kind of use at your own discretion. KubeFlow has this idea of an experiment. This is actually common to all of these tools. MLflow also has this concept called experiment. Within an experiment, we have runs, and runs are runs of pipelines. Okay, and we've got some nice archiving and whatever, yeah, other cool stuff here. Okay, Jupyter notebooks. So let's do this. So could everyone kind of follow me? This is very important to get to this step, and I'm going to rely on Antje as well too to make sure people get this step going. So yeah, everyone kind of follow me. Make sure you can get to your notebook and click on New Server. Just type your name, I'm gonna do, my name is Chris, you can do whatever you want. Don't change any of these things. If you start playing around here again, we're gonna put yourself into an unstable situation because of the rails that I need everyone to be on for at least this part here, which is the notebook setup. So let me show you guys what's going on. We've got the name. We only have one namespace called KubeFlow. We're deploying a standard. This is the 113 notebook. We're gonna, for this notebook, we're gonna allocate a fourth of our CPUs, so 4 CPUs. We're gonna allocate about a fourth of our RAM, so we're gonna say 24 gig. If you play with these things, yes, I wouldn't play with these. Down here, this should have automatically filled in your name. We're gonna create a workspace volume and dedicate 100 gigs to that. Make sure that's read write once. I wouldn't touch anything there. And here, this should already be pre-filled in, existing. This is a shared, so now, like, keep in mind that it's shared, but you only have one node. So in a multi-node case, this would be a PVC that is being shared by like multiple nodes in a distributed file system, something like the Amazon EFS. I think Google has their own distributed file system. You can use, right, like whatever else, yes, typical NFS. In most cases, most shops that we work with, because we do deal with sort of larger enterprises, they have NFS already mounted, so we would just mount that. So basically, don't change anything. Just type your name, don't change anything, and click spawn. And we need to get through this, otherwise it's going to be a very long day for all of us. So create the new server, leave all settings default, like I was just saying, PVC, and then click spawn. You should see something like this. If you're not seeing this, this will take about a minute or two to spawn. This is actually, pulling down the Docker images. It's doing all the stuff in the back. We'll actually explore the Kubernetes cluster here in a second. You'll understand more, but wait until this connect button comes up and then click connect. If sometimes when you click connect, the notebook actually has not yet started. It's still starting up, so give it a sec. But we need to be at this point before continuing. So let's give it a minute here, everyone. Yeah, DAG is directed acyclic graph. PVC is persistent volume claim. These are Kubernetes. Well, DAG is a generic computer science term. PVC is a Kubernetes term, persistent volume claim, basically pointing to stored data. Good stuff. Where to type the name? Okay, so once again, let me show you here. You should click on Jupyter Notebooks, click on New Server, and type your name right here. Type your name here. Anything you want. And then scroll down and click Spawn.
And I think some had errors in the PVC, so don't change any of the defaults there. Just really put in your notebook server name on the top.
So it looks like, okay, no capitals. Do not use capitals or special characters. So basically just stick to a simple name or just put anything in there, as simple as possible. If you start seeing PVC invalid, yeah. Is this using Jupyter Hub? Yes, this is actually part of KubeFlow is Jupyter Hub, and it's spawning Jupyter notebooks behind the scenes. So the problem here is when you start typing, this UI automatically kicks in and starts putting it down here. That's why we probably had issues with the PVC. So Vamshi, can you confirm that you have recovered from this? Vamshi pointed out that persistent volume claim VAM is invalid. Okay, so let's see. Stephen joined late. Stephen, do you have an IP address? Just go to that IP address. We're actually just getting started on the hands-on, so you haven't missed much. Okay, and I think I can send out something to ask if people are, oh, no, maybe not. Okay, a couple people have their hands up. Let's see, for people with hands up, can you type in question? You could do it to just us or to do the attendees maybe. Okay, so Stefan needs an IP address. Stefan, I assume that you've registered and we can find you in our spreadsheet here. If so, we can get you. We don't have too many to spare here. Okay, perfect. So registered. So Antje is going to take care of that. All right. So you should have. If there's anyone that is not. So a couple people have their hands up. I'm going to lower their hands. If you still have issues, let us know. Okay, so Stefan should have an IP. People are raising their hands. Is there a way to see the, oh, gotcha. Is there a way to see the logs? So yes, we will show you, we're going to show you how to do all this once we get into the notebooks here. You could actually look at the Kubernetes cluster itself. Okay, so we should have a connect button. And we see nothing, which is good, because what we're going to do, excuse me, is we're going to go to the terminal. So this is like the one goofy thing that we all have to do today. Yeah, everything else will be bam, bam, bam. So create a new terminal. So click on new and go to terminal over here. We're going to clone the GitHub repo. This is to prove there's nothing up my sleeve. You guys have everything. Someone asked before how to set this up on their local machine. It's all the instructions are in this Docker repo, or sorry, GitHub repo that we are about to clone. Okay, so I'm at the command prompt here. I'm going to send this on the chat here in a sec. I've typed this about 300 times this week, so. Okay, let me copy that. So run that, boom. And Gerard is asking about the logs of the Jupyter creation. Yes, I'm going to show you everything here in a sec. You can look at every log that is being generated. Okay, so yes. So connect to the server. Once the connect button shows, then create a new terminal. Okay, Sanjay, you sent out an IP address. Make sure you keep the IPs, yeah, private. Otherwise, people are going to hop on there. Create a new terminal. Run this command. Run that command from within a new terminal within Jupyter. Can't type in the terminal. For those of you that can't type in the terminal, can you view your, yeah, which browser are you using? Can you view your developer tools, if you have that. We haven't seen this problem before, so we might have to take, okay, Chrome. So if you have developer tools installed, can you do view developer tools and show us if there's any errors down here? Let me see, what else could be the issue? Unfortunately, I can't hold up the whole thing. We'll have to take a break here in a bit and try to work through the folks that can't do it. Okay, could not type for 30 seconds and it worked. Okay, if you're seeing WebSocket is closed or closing, refresh the browser. I'm going to do it myself. And maybe you could type there. Refreshing the browser seems to be a fix for quite a lot of things. I know it's a cop-out and it's the worst thing anyone could ever tell you, and clearing your cache and all that stuff, but really we've seen a big difference. We are actively working on the Jupyter like stabilization stuff. We're using the exact Docker or the exact Jupyter that's provided with the KubeFlow. We did that on purpose, and because we do want to learn the quirks and everything about KubeFlow, we didn't want to customize too much, especially something as core as these Jupyter notebooks, because that introduces more voodoo and more magic. Okay, it shouldn't be asking for the username and password, but if you have a GitHub username and password, try to use that. Okay, some people mistyped the URL. Let's see. Okay, so for those that couldn't type, just give me a signal that there's no, it's just a gray screen. Okay, no luck with typing. Okay, Vishal, we might be out of luck then. If there's another way you could try to debug it, we can get back to you later on here. Okay. Okay, yeah, JC, can't help you too much there. You know, again, we can't address all the like one-off configurations. Browser stuff we thought would be pretty stable, but yeah, this is our first time running this particular workshop. So, okay, so hopefully the rest of you just give us a signal if you got in, if you were able to clone. I'm going to run it again, even though it already exists. And then once you have cloned it, okay, so lots of dones and works for me. For those of you having problems, yeah, I mean, try to do your best to debug it with developer tools. We would love the feedback to know what can be done differently. Okay, so I would close out the terminal now because you don't really need it anymore. From this point on, I would click into KubeFlow TFX workshop, click into notebooks. And this is where we're going to be working basically for the rest of today. So for the folks asking about the logs and stuff, I'm going to show you guys. So back to the hands-on 0, explore the environment. So that's what we're going to do now. Oh, so yeah, I would close the terminal. You don't need the terminal anymore from this point on. We'll be sorry. Yeah, I thought I put it on mute there before I coughed. All right. Let's run this. This just gives us an idea of what we're working with here. We have TensorFlow 113. I know 114 is out, but again, when we tried to move to newer versions of TensorFlow and TensorFlow 2.0, we had some issues in the deep bowels of TFX and KubeFlow. This gives us an idea of what's currently installed out of the box. We'll actually be installing either updated versions or more packages here. Like if you notice, matplotlib's not yet installed. These will come later. Let's do a conda list. We actually have a conda environment here, I think. Am I printing out the conda version? Looks like I didn't print out the conda version, but yeah. We're using conda, we're using Python 3. That is an area I was able to work through, which is to make everything Python 3. Python 2 needs to go away to just end this pain of ours. And here's a quick check on getting to the TPU. So this looks like we can get there. Okay, and boom and boom. So this is the TPU. This is actually the internal IP to the TPU. We're running in the same zone, US Central 1A, as our TPU. That's just a limitation of TPUs. You have to be on the same network and in the same data center. And then just as kind of a fun little thing, I'm not sure how many people know this, but you could do %HTML within Jupyter Notebooks. And I've used this for some clever ways to show visualizations. Now, there's this one gotcha that's going to burn us later, I think Notebook 4, where we need to actually trust the notebook. So there's this concept. So Jupyter by default assumes that you are a horrible person and you're trying to do malicious things. So we're going to actively say trust it, because you know what, this is a throwaway server anyway, so let's just trust it. Once you trust things, things get a whole lot smoother. WebSockets work better and pages load faster. Okay, so, and I think the next workbook, oh, okay, so let me just check real quick the done with cloning now. Let's do next. So for those that just finished the clone, go back to your Jupyter over here and click on, you'll be back here, click on that, and then get to notebooks over here. And this is what we're going to be working out of. TensorFlow 113, yes. So JC, just follow my steps here. Go back here. So you were in a terminal before. So let me simulate where you were before here. And you were doing stuff here, cloning. You could actually close out this tab and go back to here, and you'll now see KubeFlow TFX. You can go to, then go to notebooks, and then go to explore environment here. One thing I would do after you run this notebook, I would click on here and do shutdown. You know, again, it's just in everyone's best interest to keep things moving forward to do it that way. All right, so Kubernetes, so the environment overview. These are all the technologies. Like I said, the very last one we're probably not going to spend too much time on. We have lots of sort of older materials on Istio, and because again, pipeline started up at the very end of the pipeline and has now backed into more of the training type workflows. So plenty of material there, but so Kubernetes. So let's take a look. To exit the notebook, yeah, just close the browser, right, or do file close and halt. You could do whatever you want. I would, okay, yeah, JC, we'll get to you during the next break, which is going to be in a few minutes here. Okay, so Kubernetes. I'm not going to spend too much time here because I don't want to take away from the data science aspect of what we're going to be discussing here, but just know that Kubernetes is essentially the new operating system. Instead of targeting Linux, Windows, particular cloud environments, what we're doing now is targeting Kubernetes. So we can pretty much do all the things that we need to do with Kubernetes. We could set up, sort of Nginx-like things within Kubernetes. We declare storage with Kubernetes. And so all of these open source projects like Cassandra and Spark and TensorFlow, of course, these are all now starting to release Kubernetes compatible like versions. So a couple years ago, all the hype was around Mesos. I personally could never get Mesos to run on my laptop or in the cloud. I always had problems. There was always one library I was missing or one error that no one could help me with. So I was very excited when Kubernetes came out. Pipeline was very early adopter of Kubernetes, 2015, 16, something like that. We did some of our very early talks and research sharing with the community on how to build machine learning models with Docker and then launching them on a Kubernetes cluster. And then we have been using Istio for about 2 years as well too. Very excited about the latest release, 1.1 Istio. We could talk a little bit about that later. But just know that all of the cloud providers, as Amazon just released, I think it was summer or fall of 2018, so less than 1 year ago, they had released something called EKS, the Elastic Kubernetes service. And so now all of the 3 clouds, Google, Amazon, Azure, all now support Rally Kubernetes natively. So this is great, except there's always those times when you still need to have something cloud specific, either the Docker registry, like we actually have one notebook today that depends on the Google Docker registry. That's actually pretty easy dependency to snip, so we could talk about that in a bit. But yeah, so just as long as we can now get to a Kubernetes cluster, we can have true multi-cloud or hybrid cloud type of environments, because you can run Kubernetes on-prem as well too, and you could actually have these clusters all join each other and become one federated cluster. The terms that we'll be using within Kubernetes, we'll be talking about nodes. So in our world today, we have one node. I'm on a machine that has the 16 cores, 100 gig RAM. That's one node. We could, at the end of the workshop, join all the nodes into one big Kubernetes cluster. Could be kind of fun. Could also take up the entire afternoon and not actually add any value, but in theory, this is something you could do. You could scale out to multiple nodes as your workloads increase. This is all handled by Kubernetes and in conjunction with the cloud providers themselves. So you could actually tell Kubernetes or configure Kubernetes to tell the cloud provider to spin up more EC2 instances or more Google Cloud instances or Azure instances as the workload increases. So this is where we see specific working groups within Kubernetes. These are teams of people that have gathered together to make sure that Amazon works well with Kubernetes and Azure works well with Kubernetes. So this is a very, very large community, something we did not see with Mesos, which was more of, sort of an open or sort of a smaller closed environment than Kubernetes. So Kubernetes comes from Google based on their Borg sort of internal container management system. Yeah, let's see. The other things we'll be talking about, a little bit about monitoring, placements. There's only one node, so these all get placed on the same node. But scaling, we just talked about a little bit. All right, so let's take a look at our Kubernetes cluster. This is actually one of my favorite things to do since I spend a lot of time in Kubernetes. So let's do a quick run here. So these things are called pods. So we'll be talking about nodes. We'll be talking about pods. Pods are what gets scheduled. And pods contain one or more Docker containers. All right, so I'll say that again. The Kubernetes pod, on average, contains either one or two, typically one or two Docker containers. If you just think of a pod as a Docker container, that's okay for now. When you start doing more complex Kubernetes, you'll start dealing with multiple Docker containers within a single pod that share the same private networking. So if you're familiar with Docker, you know that the second that you move beyond a single Docker image, Docker container, these containers need to talk to each other. This is typical 3-tier where you have client, you have application server, database, right, back in the old school. these things need to like talk to each other. Either you could, build all of these like routing tables yourself, or you would use Kubernetes, and these pods can now like talk to each other through what's called services. And we'll talk a little bit about those here in a bit. So by the end of the day, you'll actually be familiar with pretty much all of these. So Chris-0 is my notebook server. So that's what's actually powering. If I go and look at the logs on that notebook server, I'm going to see what's going on. Someone asked about, show me the logs on spawning. Spawning is done by this notebook's controller. So a concept in Kubernetes that you'll see over and over is called controller. Controller is a loop that's just constantly looking for changes in your cluster, things that you want to change. If I say scale up, add 10 more instances of like Airflow, or 10 more pods of my Airflow workers, I would do a kubectl command, which is the Kubernetes CLI, and I would say scale, and I'd say Airflow, and I'd say 10. And the controller, there's an internal Kubernetes pod controller that's out there listening that can then sees that a change has been declared or requested, and then can operate. So whenever anyone builds their own form or something somewhat complex, they typically end up building their own custom controller that keeps an eye on these notebooks. So when we click spawn before, we declare that we want a notebook called Chris-0. This notebook's controller saw that and then spun it up. And the end result is this pod. Now there's some other concepts here. There's concept of a deployment, which actually manages multiple pods. There's something called services, which is how these things talk to each other, either publicly or internally. Not going to get too much into that, again, because I don't want to get too buried in DevOpsy stuff. I would rather kind of focus on how data scientists, or how the application engineer or the ML engineer would actually use these things. And fortunately, KubeFlow hides a lot of this. I'm showing this to you because if you do want to look at logs and dive deeper during some of the breaks, this is the place that you would go to. Okay, so I'm going to take one of the pods. Let's actually take that notebook controller. So I'm going to click here, grab the name of this pod. This garbly goop on the end here is generated by Kubernetes. So we deal, and sometimes that's not the case. Sometimes, like depending on the type of resource, it will not generate fully garbly goop. This is actually a hash. What's the implementation detail here? It's a hash of a combination of the name with the timestamp or something like that. So these will end up being somewhat unique. Okay, so I can copy and paste here. I'm going to put in the name of that controller. I'm going to describe it, or sorry, the name of that pod. I'm going to describe it. It's going to tell me what's going on here. Typically, pods are controlled by what's called replica sets, which handle the scaling. Let's not get too much in detail. This is the command that I think some of you might be looking for. And this follows the Docker convention here of Docker logs -f. Also, we'll see later Docker exec. There's a kubectl exec where you can actually hop onto the pod itself. So these are the logs, kind of chugging along there. Here we'll see that it created the container called Chris, and that's what actually led to the creation of that Chris-0 pod, which is physically what is running this Jupyter server. You could do that with any number of these pods. If you're curious, you can look, I guess you could look at the Chris-01 or the name of yours, see what's going on in there. Dashboard is actually this dashboard right here. Powers that. And okay, so Airflow is what we will be doing here in a bit. I think the next labs will be spawning the Airflow pipelines. Khatib is actually what is doing the hyperparameter tuning. If you're familiar with hyperparameter tuning, some of these terms should look familiar. Bayesian optimization, grid search, hyperband, random search. we can actually run logs on these later on today when we do the hyperparameter tuning exercise. So Vizier, that's probably not how you say it, but that's how I'm going to say it today, is a paper from Google, and these are implementations of the Vizier paper. So this is the other super exciting thing about KubeFlow, is that we're starting to see what used to just be white papers actually being built by Google and put into the open source. So these are very, very common hyperparameter tuning algorithms that have that are now fully open source, and they're now packaged up as part of KubeFlow. Let's see, here's a Redis cluster, which we'll use here in a bit. Actually, Airflow uses that for some performance improvements. MySQL is there. Here's the MLflow. So when we do MLflow exercises, we can come back to this notebook and then take a look at what's going on behind the scenes. And then this is the core of the KubeFlow stuff. So when we launch a KubeFlow pipeline, we can take a look at the scheduled workflow. If we're interested in the UI stuff, we could do that. Minio is that server, like I said, that kind of sits that pipelines can use to abstract away, and so that you could portably take your workflow or your pipeline and move it from cloud to cloud. And all you have to do is behind the scenes tell Minio that you're using Google Cloud Storage, or you're using Azure Storage, or you're using S3. Ambassador is actually doing some of our kind of front door sort of Nginx type of routing. We also have Airflow, we have Istio, which I think, for those of you interested in looking at Istio, you can do kubectl get pod namespace istio-system. You should be able to see, unless the RBAC stuff is messed up, but. Okay, and this is one of those times when, oh, might be because I did a logs-f, and that's doing a tail. So whenever you guys get into trouble or something's not working, I would do the following. And this is an example where stuff's a little bit frozen. I'm going to click the not trusted, because I'm going to trust it. I'm going to refresh my browser because I'm paranoid, and that seems to help sometimes. And then I'm also going to stop and then restart my kernel. And if you really want to get crazy, which I would actually recommend, you would go here, shut this down, which is different than stopping the kernel, it appears. Come back here, restart the kernel. We're going to be doing this quite a bit today. So you have to put an exclamation in front here, or a %bash to run bash commands. And, okay, so we actually have the RBAC locked down, which is good. So while we do have Istio on here, and it's actually serving MLflow and a couple other services, we're slowly transitioning off of Ambassador and onto Istio. This is actually a trend that's happening with the larger KubeFlow community. KubeFlow 0.6, which is the next big major release, will be using Istio and not something called Ambassador for the sort of Nginx or the Apache server like routing. Okay, so I'm going to go over here. I'm going to be a good citizen and increase my chances of success. So I'm going to hit shutdown. I'm going to go back to this. And I think we should take a break. Let's do about 15 minutes. A couple people still have their hands up. I'm going to look through here.
And we had one good question coming in, Chris. So one person asked, they don't see the KubeFlow pod running, and wondering where that one is.
Okay, let me see. Not returning.
So if you do the Kubernetes, like the get pods command, and they were wondering how to figure out where KubeFlow is running.
Okay, so I think this is what I just hit, which was one of these commands is a -f, which actually is tailing the logs. And anything after that doesn't seem to get run until you stop the kernel, restart, shut down. So I see the question here.
And KubeFlow isn't really like a single pod, right? So it's a combination of a couple of services running within Kubernetes that form KubeFlow.
Oh,
if you want to elaborate on it.
Okay, I didn't see that. I saw the question, kubectl describe pod is not returning. And that was the case I just dealt with, which was the person was likely doing it after this tail, this -f, which just will spin on this thing as new data is coming in. Yeah, prepend, bang. I'm trying to grab an actual pod name. Okay, someone said don't forget the okay. Where's the question about the kube? Okay, we'll get to the questions here in a bit. Let's return at 10:25 a.m. PT. So let's get about 13 minutes and then we'll go through. Let's see a pod for KubeFlow. Curious where it is running. Oh, KubeFlow. Sorry, I was confusing all these terms. Yeah, myself here. KubeFlow is a combination of a bunch of these. So the main KubeFlow, as you will see it here in a bit, is going to be these, the ML-pipeline. But really, all of these are KubeFlow. Like this comes from KubeFlow. This is the actual UI itself. Argo is part of KubeFlow. This Vizier stuff is part of KubeFlow. 13 minutes. Okay, and looking here is Jupyter Notebook. The Jupyter Notebook server is part of KubeFlow, yes. We intentionally use the same distribution, the same Docker image that is packaged up with KubeFlow. Let's see, someone's at, can you show the last? So the Istio commands to show Istio won't work because of RBAC. So we installed Istio into what's essentially a system-wide Kubernetes cluster that can't be seen from the notebook. If you were to shell into the instance, you could see it, but just know it's a standard Istio 1.1 installation. Okay, Siren, let's see. Okay. Okay, people are asking about Spark. Can we target the Coral dev board? You could build a model that could be exported to the Coral dev board for sure. Created to see. Yeah, so there's a question here about Spark. And yes, Spark is certainly supported. So KubeFlow's Jupyter notebook is just kind of a best effort, core. In fact, let me send you guys the link to the actual Docker image that's used. You can either extend it, and in KubeFlow, you could, so I have it disabled right now because I'm trying to keep everyone on Rails for this workshop and not get into too many one-offs, but you would have a list of notebooks that you could choose from. So back here, and I wouldn't do this right now, but just, so this dropdown would actually contain all the custom images. You could even select custom image and choose a different image. I wouldn't recommend it because we can't support it right now, but you can specify your own Docker image that has Spark and has everything installed. I was trying to get Spark to work today. I ran into some instability the last couple days and decided not to focus on Spark today, but we still do have MLflow in here, which is more in line with the topic of today. But yes, you can do whatever you would normally do within a Jupyter notebook, you could absolutely do within KubeFlow. Yes, slides and video will be available after the workshop. GitHub is, so yeah, and I think you guys already have the GitHub. I'll save the typing there. Regarding Spark, the latest versions of Spark support as a scheduler. Support Kubernetes as a scheduler. So this is 2.3, Spark 2.3, Spark 2.4. You can Google, or I could Google, I guess. Spark, Kubernetes, running Spark on Kubernetes. This is in my cache because I was just looking. So think of it more as Spark on Kubernetes and less Spark on KubeFlow. KubeFlow is an application running on top of Kubernetes, just like Spark would be an application. We're going to show you guys later on today how to dynamically create a Docker image and deploy it to the cluster. This is in the context of XGBoost and training a model. And the same concept would apply with Spark. You could actually create the Docker image and then launch a Spark job. Yeah, this question about Yarn and Kubernetes always comes up. If you have, so I would, as best as possible, keep Spark on Yarn and just keep that the way it is, and run KubeFlow on Kubernetes and just keep them separate, and then join them only at the data sources. That's my recommendation there. Kubernetes plus Yarn, I've never actually seen that in action. And whenever you start ripping out schedulers, especially within Spark land, there's going to be lots of weird issues. And Yarn gives you the ability to actually debug logs on the nodes itself, and get sort of worker side node logs, and you could potentially lose that if you're not careful about your Kubernetes implementation. The short answer is Spark plus Kubernetes is very new, and Spark plus Yarn is very proven, and stick with Spark plus Yarn. Yeah, Saren, I don't know much what more I can do. Can definitely give you the refund if you want to bail out. But yeah, I would stick around. There's still going to be some good talks here. The notebooks are all available GitHub. Again, from okay, Stefan asked about 2.0 on KubeFlow. Yes, we had intended on using TensorFlow 2.0 with KubeFlow. This is actually some of the slides. I think he joined late, some of the early slides. But TensorFlow 2.0 with KubeFlow is a little bit wonky, and KubeFlow supports it, sort of. It'll support it in that it will let you use TensorFlow 2.0. It's just all of the examples and kind of the meat of this workshop really ended up being, TensorFlow 1.x. And my attempt, I first went through and upgraded everything to Python 3. That was okay. I then started going through and moving things over to TensorFlow 2.0, and even the TPU stuff was broken. TFX was the samples, and all the libraries were breaking in random places, and I just didn't want to deal with it. Yeah, Saren, it's hard to debug. If there's any more logs that you could send to us, the panelists, and give us screenshots, email support at Pipeline AI with whatever screenshots you have. we can work with you offline and get you into the next workshop in in a month. Oh yeah, someone suggested you can clone the repo locally and then upload. It's an awful lot to upload. Okay, so someone's asking about what is the deployment of KubeFlow. So I think what you're asking is which of these pods is KubeFlow? And my short answer is going to be they're all KubeFlow. That's the best way to start. The ML pipeline stuff is certainly KubeFlow. MLflow is not KubeFlow, it's actually MLflow. This is KubeFlow, central dashboard. Argo is part of KubeFlow. Jupyter web app is part of KubeFlow. Notebooks controller, KubeFlow. Study job, this is for hyperparameter tuning. All the Vizier stuff is KubeFlow. KubeFlow has gone beyond a single sub-project and is now made up of about 10 or 12 different sub-projects. So that's why I'm saying just assume that everything here is KubeFlow except Airflow and MLflow, which probably doesn't help too much. But if we go to KubeFlow itself, we'll see this is more than just the core KubeFlow. This is actually pipelines, TF operator, Katib. This is so part of what we're doing today is learning these terms so that you can then Google and go and find stuff and figure out what suits your particular setup. When you install KubeFlow, you kind of have the option to choose what you do and don't want to install. That's actually under construction right now because it's using something called KSonnet, which is like, if you're familiar with Maven or Ivy or pip, like PyPy, KSonnet was meant to be the KubeFlow way to install packages. They're in 0.6, they're moving from KSonnet to something called Customize with a K, which is pretty much the same thing. Or in concept, it's the same thing. But there's a whole ton of projects here. Fairing, this is what we'll use later to deploy the XGBoost notebook. Pipelines, this is really what finally got us at Pipeline AI to start using KubeFlow. KubeFlow was pretty much useless to us until this pipelines project came out. Pipelines is, this is what we'll spend most of our time on. And back to the notebooks, pipelines is this ML pipeline stuff here. Combination of that and this Argo, but mainly this. KubeFlow does work on OpenShift, absolutely. Okay, Anshay, we got some Q&A. Tried it. Okay, question here is KubeFlow installation. So the question is about KubeFlow with on-prem. And to me, on-prem means sort of the inverse, which is not cloud. So, or not cloud specific, right? So for me, I'm still going to use a cloud. I just don't want to be cloud specific. So, but the answer to both these questions is we've done all that we can possibly do to snip all of the cloud specifics from this workshop. So the version that you're using here is as close to on-prem as you could possibly get. Are we going to cover anything about managing Kubernetes via Helm? No, I'm personally not a big Helm fan because there's too much voodoo and there's not enough exposed. Like there's not enough configuration elements exposed, and I always end up having, I generate using Helm and then I just customize the YAML that's generated and then I commit the YAML that's been generated. So we won't be doing any Helm today. Really, we've installed as much as we can. This is not a DevOps workshop. I'm trying to keep it more at the sort of application layer, the data science layer. But you could certainly package, there are Helm charts for various KubeFlow components. KubeFlow, like I said, uses something called KSonnet instead of Helm. You can probably combine them any way you like. I'm just giving you my own personal preference, which is every time I sit down to use a Helm chart, it's either broken or it needs so much customization that there's no point in me using Helm anyway. This actually happened with some of the Airflow stuff. And yes, you tried the on-prem installation of KubeFlow a couple months ago. Even 1 month ago, when we started building this workshop, it was very difficult. We spent the last month snipping dependencies as best as possible. Okay. Okay, so it's 10:25 here. Let's keep going. So it looks like Siren still has issues. Just keep giving us info on that. We'll try to answer them. Okay, let me go back to, so TFX. Okay, TensorFlow extended. So this is the mothership of all like machine learning pipelines. You know, again, this is what Google's using internally. They have papers about it, very interesting papers. They reference the age-old concept of machine learning technical debt. So building up tech debt in your machine learning infrastructure, how do you deal with this? KubeFlow, TFX, these things are designed to try to reduce the complexity and let you focus on the data science tasks. So TFX is this broader concept. Airflow can execute TFX pipelines. KubeFlow can execute TFX pipelines. Today we'll see examples of both. This diagram will be repeated on pretty much every slide between now and lunch, so keep an eye on this. Or don't feel like you have to memorize it right now. It's going to be in the upper right of every slide as we go through each piece. So at a high level, we need a way to load data. In machine learning world, these are called examples. In TensorFlow land, there's actually something called TF example. And examples in a machine learning context are essentially rows or observations and used for training data. Statistics. So we want to analyze all of these features, the inputs that come in. So this gets back to what I had mentioned very early on, which is we want to look at the overall distribution of all of our data. So this is most useful when we want to make a full pass over all of the data that we've loaded. Now we don't have to load it into memory, right? But we want to stream through it. And internally, you'll see references and error messages and warnings that are related to this project called Beam. And it's an Apache project. Google pushed it out there. And it's essentially a way to do streaming. It's kind of a set of interfaces and also has a simple kind of local way to stream through data and to do like windowing and to track mins and maxes and track and sort of analyze the overall distribution. So the mean, the variance, these are very useful things when you're doing your feature engineering. So we're still not training yet. We're just looking at our data. And we have notebooks dedicated to each of these steps. So just hang in there. We want to validate our input data, the examples. We want to look to see if there's missing data. We want to see if there are certain features that are so wildly out of, that the scale of, so let's say one feature is in the order of tens of thousands, and a second feature is age, which is, right, like 0 through 100, something like that. These are wildly different scales. And what that means is we should be normalizing this data, right? Like getting the broader, or the closer scale that we can get to, our model can actually learn better, can learn faster. So said differently, we want to normalize data as much as possible and keep the scales of each of our features as close to each other as possible. Okay, and so that's something we could do by taking a look at the overall, that step before the feature analyze step, and then now we're in the third step of actually looking at all the data. We can generate a schema. If you're familiar with Spark, which it looks like some of you are, we can actually generate a schema just like Spark does based on the input data. You'll see TensorFlow tends to use protobuf, which is just like JSON, but cryptic and binary. But tighter, cleaner, smaller, faster, faster on the like wire too when you're sending stuff across the network. So, but the concept is the same. We're looking at all of the data. We're generating kind of the canonical schema for all the data that we've seen, and we can now start to detect outliers or certain fields that or types that we weren't expecting. We can then do feature transformation. We have a whole notebook on this. And we can then ultimately, so after all of the feature engineering and feature processing, the feature normalization, we then can train our model. And then afterward, we want to evaluate the model on some holdout training data set, which comes from all the way on the left there. There's the training and eval data. So we would hold out, 10%, 15, 20% of our training data with the known label, the known prediction, and then we would pretend as though we don't know the prediction, and we would run it through the model, make the prediction, compare it to the actual prediction, and then come up with a score for how well that model is. This is then used for hyperparameter tuning. So as I mentioned before, each of these models can take in different parameters just based on the type of math that's happening beneath the covers. The kind of simplest would be decision tree. If you're using a decision tree, one hyperparameter is the depth of the tree, right? Like how many levels deep do you want to go? You could choose 10, you could choose 5, you could choose 500. Which one's going to work best? Well, that's why we're doing the evaluation. That's why we're holding out known data with that answer key, with that known prediction, pretending like we don't know the prediction, and then comparing it to the prediction. Once the model's validated, we can then automatically push it out. And we'll see this directly in Airflow here in a sec. So if you kind of infer from this diagram, you'll see that TFX really is the sort of larger mothership of all ML pipelines, and really has some really good concepts, some decent sort of implementations, reusable libraries. One of the things we'll be doing in 3 or 4 of the notebooks is actually generating visualizations within our notebook and slicing data and looking and seeing the outliers and seeing where we need to normalize. And we'll spend quite a bit of time doing that. But what you'll see sort of subtly, those tabs up top, Airflow, KubeFlow, other, Airflow is just a way to coordinate TFX. KubeFlow, also a way to coordinate TFX. So the key takeaway here is you can use TFX right now in all of its glory with just Airflow and not even bring in this beast called KubeFlow. Now, KubeFlow is a beast and it's complex and there's a lot of pieces. It's because the tooling isn't quite there yet. It's 0.5 release going to 0.6 in a couple weeks. But at some point, there will be tooling that will generate the Docker images for you behind the scenes. So you won't have to think as much about the systems side of it. So back to the pusher. One cool thing is we could actually introduce a model validation human in the loop. And there's a component that's built into TFX that can actually post to Slack and send a Slack message and with a link to the trained model and to the validation results, and ask the human to click on the link to take a look at the results and then respond back with /LGTM, right? Like looks good to me, or /deny or /decline. There's a couple different ways. If you do looks good to me or yes, it will push the model into production. And then at that point, you would have the Istio routes and other things that could slowly route traffic, 20%, 30%, sort of a dialed approach is what we called it at Netflix. And then the underlying thing here, this is something that actually is a bit confusing about the overall TFX KubeFlow world, is this metadata store. And no one quite knows what this thing is. It's hard to even get Google people to tell you what it is. Like, they all have slightly different answers. We're going to crack this thing open and start looking inside of it and see what it's tracking. Just know that it's really the gateway to reproducible like model training. And we can record in this metadata store what happened after each of these component steps. We can also record the versions of data that were used at each of these steps. We can record any observations, like we had this many outliers, we had this many missing values. Think of it just kind of like a dumping ground of all of the inputs and the outputs of each of these steps, with the version numbers and paths to S3 and whatever else. And the output, in a lot of cases, the model deployment is literally just a Docker image with a Flask app, or if you're going to do it the pure TFX TensorFlow way, you would use TensorFlow serving. You could also deploy to TensorFlow Lights, which will automatically quantize and simplify your model, make the math quicker, make the model smaller so it can fit on super tiny devices. You could also deploy to the browser, which is crazy, TensorFlow.js. And then there's this how do I call it? I guess it's really a website called TensorFlow Hub where you could upload your models. And there's already a whole bunch of TensorFlow models out there. If you're familiar with Spark, you might remember something called Spark Packages, which was a place where you could put Spark components or Spark libraries that you built that you wanted to share with the community, but did not go or would not make it into the Spark core. So TensorFlow Hub is nice. I honestly don't know anyone that's really using it. People usually train their own models and keep their own. I mean, that's the whole point of training these models, is that they're sort of proprietary to your domain. But this is where you'll find a lot of the sort of public models. All right, let's keep going here. All right, so I think we're going to kick this off here. Airflow, ML, Python. Oh, actually, this is still kind of an overview part, and then we'll actually get into the hands-on here in a bit. This is what we'll be doing in a bit. This is the Chicago taxi. These are all the exact same steps. So if you remember, there was the example gen, which is that thing on the left, statistics gen, schema gen, example validator, transformer, trainer, the model evaluator, and then the pusher. Here's the KubeFlow version. So you see data validation. Let's see the actual, so there's transformation there, there's training, predicting using the output of that same data validator up there. We can actually generate confusion matrix and the ROC curves. Then we'll be exploring hyperparameter tuning. So this is a way where we're actually going to generate a random search over a space, get the results. This will, in parallel, spin up a bunch of models to train using different combinations of hyperparameters, and then maintain the outputs or the validation data of each of those runs. And then we could figure out what are the best hyperparameters for a given data set and a given model. So pretty cool stuff. We're not going to get too much into this, like I said, but just as kind of a high-level overview of what Istio is. So if you remember, I mentioned pod earlier, and pods can contain multiple Docker containers. This is a case where we're packaging up a traditional microservice. Think of it like a REST API that your application team builds. We package it into a pod with something called a sidecar. And this is a concept that comes out of Istio that you can send all networking through the sidecar so that you're never actually calling the microservice directly. You are always dealing with the sidecar. If the sidecar deems that that the microservice should receive that traffic, it'll send it over. If not, it'll pass it on to another pod. Or maybe this is where we're doing our 20%, sort of A/B test, where we're sending 20% traffic to the new model, sending 80% to the current model. So this is all handled beneath the covers. Yes, Istio actually relies heavily on a project called Envoy, ENVOY, that came out of Lyft. Very, very low-level stuff, networking stack written in C, very highly optimized, that can do this sort of traffic routing. So the clients, maybe you have like a Netflix device, or you have some sort of calling application that calls into the backend microservices, will actually deal with like Istio and not directly calling these microservices, which is pretty cool. This is something we had always built, even back at Netflix. We were always building this type of thing. And one of the things, or like reasons we chose Istio very early on, when it first came out, was it followed a lot of the same architectural patterns and sort of high scale patterns that we had implemented at Netflix back in 2010, 2011. Circuit breakers, all the fancy stuff where if a microservice is starting to get too much traffic, we can flip a switch and we would open a circuit basically and start to reject traffic, or start to return suitable fallbacks. Maybe we show top 10 movies of all time versus the top 10 movies personalized to that user for that moment. All right. So this was kind of an overview here, just to show, just covered all of these things at a high level. We did some hands-on exercises. Let's get a little bit more into TFX so we can keep an eye on the time. So let's talk about the internals of TFX, the TFX libraries, and TFX components. So each of these here, the example gen, statistics gen, are all components of TFX. Each component is made up of these TFX, these rather internals, we'll call them. And then TFX libraries are used by all these components. So yeah, we'll see how all this comes together here in a sec. So each component is made up of a driver, an executor, and then the other, so when you go to actually implement your own component, so for example, the Slack, that Slack component, there's this concept of a driver, the executor, and then publisher. So driver is what's actually sort of coordinating. The executor is the thing that's actually running the actual code, and then publisher publishes the results, right? So the driver can actually take data in from that metadata store, passes it to the executor, and then the executor passes the output to the publisher. So, kind of a simple concept, right? Yeah, like this isn't rocket science. I'm just giving the terms that are used within TFX. That like metadata store can do quite a bit of stuff, can handle lineage info, can handle artifacts, right, like saving artifacts, tracks all the inputs, outputs, and contains versioning info. Some people might be thinking, okay, well, there's other technologies and other open source projects to manage versions. There's something called Pachyderm. There's right, like various ways to version like data sets and version the outputs. Even some of these tracking projects, right, like MLflow, have their own way of right, like tracking all these inputs and outputs. So this is a decision that like you'll have to make. Right now, the current state of things is this metadata store is backed by either MySQL, SQLite, on disk, in memory. There's like various backends. What you'll see with MLflow is, because Databricks is very cloud savvy, they have S3 backends. Because Databricks also is now part of Azure, there's an Azure backend, and I believe it's also Google Cloud Storage. So it's up to you. If you're in Spark land purely, I would stick with MLflow and just let the Databricks guys keep refining that to work very well within Spark. Fortunately, they are keeping things very open and not trying to like package it and sell it with the actual Databricks product. So that's really nice. If you're in like TFX land, you can give this metadata store a shot. Make sure that you're using something with persistence. And I believe there's also Minio support that's coming. And I don't think there's Google Cloud Storage support. I might be wrong on that, but I've spent the last month trying to snip all those things. So I've been focused more on kind of the non-cloud version. All right. Here's the TFX library. So this is how we will talk for the rest of the like workshop here, which is, so the components are these high-level things: the example gen, statistics gen, transform. These things use these libraries. Now, these libraries can be used outside of components, which is why they've been put into like libraries. These are actually pip installable. In fact, we'll be installing them in our notebooks here in a bit. And this is data validation. This is what's going to take a look at all of our data, give us statistics, give us the mean, the variance, tell us outliers. TensorFlow transform is kind of a standard set of like, so this is TFT, standard set of like libraries to do feature engineering. The TensorFlow model analysis, this will, after the model has been trained, will give us metrics on this. The cool thing is that the schema that we generate in this schema gen back here can be used both during training and during serving. So we can actually validate that when like data is coming in to our model during prediction time, either behind a REST service or behind TensorFlow serving something, that schema is being maintained. And then let's see. So a lot of our time will be spent, I think it's notebook 4, TensorFlow model analysis. That's going to do the slicing and dicing. So like TFMA is really slick in that it'll let you pretend as if, so you've trained your model, and now you can pretend as if the only data that it's seeing is ages 25 through 40 and see how the model reacts. And so this way you can sort of slice your data, like take sections or rows of your data and only expose the model and see how the model is going to predict. So this way you can start to look for biases towards different age groups or biases towards different races or towards different subsets of your data. So row slicing, right? So we have a pretty cool notebook on that, and which we'll unleash here in a bit. So TF metadata and this concept ML metadata, you'll see these acronyms. These are really the storing of the lineage and like artifacts and that kind of thing. So we'll see these, but in the context of sort of other uses. All right, so here's an image of what the kinds of things that we would see with the data validation. So this is really in the feature analyze area. Find missing, redundant, important features. So we can do sort of PCA-like, where we're finding the most important features, the principal components. We can find features with sort of wildly out of range scale, which is a signal that we need to normalize that like particular feature, that particular column. We can generate a schema, which is very useful. This will also help to detect data drift. So the next time that we run the model, or so we are always calculating like statistics on the entire data set. So this is an example of a non-uniform distributed or non-uniformly distributed data. So basically non-uniform, it's skewed towards a particular like value, and then this is more uniformly distributed data here. So we could see nice even distribution, And here we see spikes along one particular subset of the data. Okay, so let me just double check time. We're almost at 11. So I'm going to answer questions for the next 10 minutes, and then I think we should take about 15 minutes to do this. So, all right, so let's do this. Let me just simplify this here. Let's return at 11:15 a.m. Pacific time. Please try to run. Which notebook is it? 02 TensorFlow validation. And see how far you get. I'm going to take a break so my voice can recover here. Let me look at the questions. Okay, still some. Okay, we'd love to hear more about the dialed deployment. Yeah, so deploying in a dialed, we called it dialing at Netflix, where we would deploy a new version of the backend service that we implemented. Let's say we were implementing a new version of our personalization models. We didn't want to flip over all 100% of our users to that new model, just in case there was either something wildly wrong with the model, in case we implemented the model in a way that would blow like JVM heap, or would hit some strange bug that we didn't know. So dialing is a way to control the amount of traffic. And what you would do is you would essentially take their customer ID, which was part of every Netflix call, and you would hash it. And if it, then you would mod it, somehow. And certain customer IDs or subsets of customer IDs would see the new model. Certain ones would see the current model. And that way, we would slowly dial. And then there was this like little admin screen that was built into this whole framework, where you can then change it to 20%, and then 50%, and then 75, and then 100. Okay. Let's hear more. Okay, PyTorch. PyTorch is supported by. So you can do whatever you can do in Airflow, or sorry, whatever you can do in Python, you can do in Airflow. So there's a question about Airflow and PyTorch. There's nothing specific about TensorFlow with Airflow. You can run all Python code within Airflow. And if that happens to be PyTorch training, absolutely. Yeah, the Slack integration thing is super cool. Okay,
there was one question. Yeah. Sorry, Chris. There was one question. How do you stream data into TensorFlow or TensorFlow Extended, if you can use Kafka or Pulsar as a source?
Gotcha. Let's see. So yes, Apache Beam is the interface. Think of it like an interface. It has a local, simple, kind of basic streaming implementation that's written in Java. There are implementations of Apache Beam for Spark streaming, so you could actually use Spark streaming to get data in, which can pull from Kafka, which can pull from anywhere. There's a couple things popping into my head with Kafka and TensorFlow. In TensorFlow 1x, there was an implementation of the data API that could read in Kafka as though it was a file system or any other. And we actually used that quite a bit. They pulled it out of 1x because it was part of contrib, or they pulled it when they moved to 2x. So it's actually not there, and I don't even know where it came from, because the only place we're using it is a TensorFlow 1x shop. So not too familiar with Pulsar, but the out of the box getting data into TFX is done with Apache Beam. And because Beam comes from Google, it's there is the project name within Google, was it DataProc or DataFlow or something? There's a really good implementation if you're specific to Google that can, where it's basically like Kafka. Okay, Slack integration, deploy model as a Docker image with Flask. How will it get the data? If you deploy your model inside of a Docker image, and Flask is fronting that model. So Flask is basically a web server written in Python. Data comes in through the web server. So people make REST calls. So you would, just like you would do like a browser get or a browser post, data is, so the Docker image is built, and then you run the Docker image as a Docker container, either on a Kubernetes cluster or on somewhere else that can run Docker. The data comes in through the Flask front door, that web server. And similarly, when you make the prediction, you would send that prediction back to the caller. Now, we're almost complete with a Kafka Streams version that can do the same thing, where you would deploy the model as a Docker image, and inside that Docker container, when it's running, it's listening on a Kafka stream. And it's pulling data, it's making predictions off of the input stream, and then posting the predictions, the actual outputs, onto an output stream. So we have a stream coming in and a stream going out, basically. But in the middle is this Docker container, or in our case, it's a Kubernetes app that is listening on these streams, taking the data and moving it between the input and the output streams. Yeah, so it looks like Gerard mentioned expose the endpoint in Flask server. Yep. TFX with PyTorch. Yes, yeah, so TFX, so really, we're using TensorFlow here because that's what the examples are, and that's what we spend about 80 to 90% of our time working with at Pipeline is TensorFlow. We are starting to see more and more PyTorch. We're starting to see more and more samples of PyTorch. To date, I've always had problems with them. Either the version of PyTorch was out of date or something was wrong. So this particular workshop doesn't have a whole lot of PyTorch examples. We do have XGBoost and some other ones, but yeah, I imagine in the future this workshop will have more PyTorch examples as more and more of our customers adopt it. Yeah, so Istio is, you would introduce Istio when you want to do the more complex dialing, and you can even mirror traffic with Istio. So that's a primary use case that actually Pipeline was built on, was the ability to mirror traffic so that you could, instead of dialing and choosing 20% of people to get the new model, which might be crashing, you could actually pretend as though these people, so you would basically make two predictions. You would, for one user coming in, you would call the current model, which would then return back to the caller. But you would fire this asynchronous call to the new version of the model and store the prediction, and then compare the current model to the new model. So this would be fire and forget. It would be best effort. It's not going to affect production if implemented properly. But it's doing this traffic mirroring where it's taking all the requests that come in and calling the B version, C version, D version of your model that you're testing. So that's pretty slick, but you don't want to build that on your own. It seems pretty straightforward, and yeah, you could do it with Lua scripts and Nginx, and but really, yes, Istio is pretty slick and has some nice tooling that will let you change those percentages on the fly. You could use Seldon. Yeah, Seldon's pretty good. You can actually use Pipeline for the same thing as well too. So in some senses, Pipeline competes with Seldon on the model serving, but we've also now moved more into the complete pipeline, as our name Pipeline AI implies. Yeah, it's like someone found an old video of mine. Good stuff. Thoughts. Kubernetes versus Docker Swarm. I've never personally used Docker Swarm in a production environment. To me, it was a stopgap until Kubernetes, kind of gained popularity. In fact, Docker now, even on your Docker Mac or Docker for Windows, supports Kubernetes as well as Swarm. I know of one production use of Swarm, but yeah, even that group is moving over to Kubernetes. And I guess besides my personal preferences and what I see in the field, and this, the community behind Kubernetes is massive. And if you just look at Kubernetes and Swarm, you might not see that many differences. But when you look at Kubernetes plus Istio or Kubernetes, plus KubeFlow, right? There's a huge community that is treating Kubernetes as just an operating system. So I've said this before, where when I'm at a conference or speaking to a group, I ask who here uses Kubernetes, and it's like 99% of the room now. And basically, it's as silly as asking who here uses Linux or who here uses Kafka, right? My point there is, we'll get to a day when we don't even talk about Kubernetes, or we're just going to talk about applications being built on top. And let's see. This validation module has a cross-validation. Does allow configure custom. That's a good question. We would have to dig in so the validation. And here you're talking about model validation, obviously. So the notebook that we're on right now, just to be clear, is the data validation, where we have not yet trained the model. We're just validating inputs. But when we get to the model validation, let's take a look. And yes, I know what you're getting at, which is you would want to do something like a k-folds cross-validation, where you that concept before I mentioned, where you hold out data and then pretend as though you don't have the answer or that prediction, and then make the prediction and compare. And then you would do that 5 different ways by holding out 5 different subsets of data. I don't know why it wouldn't have that, but let's take a closer look at the data validation module when we get there. Yeah, and so dialing, yes. And actually at Netflix, the primary use was dialing to do canary. So, canary is kind of the DevOpsy way of saying A/B test. So really, to me, they're the same. But really, the next step beyond A or B is A and B testing, which to me is the traffic mirroring, traffic shadowing. But yes, like people use customer ID and various ways to do canary deployments. The crappy thing about an A or B or a canary deployment is, if something goes wrong, you're still affecting that small percent. And so if you're doing 20% or even 1%, 1% of 150 million Netflix customers is still quite a lot of customers, and they're in a degraded state. And if you can do the traffic shadowing, and it's an asynchronous, they're still getting the answer back from the original model. So they're in a good state, but you behind the scenes have a dashboard that's showing the comparison between those 2 predictions, between those 2 models. Yeah, so Spark streaming, let's see, if you Spark stream the data, convert the Spark data frame to Pandas data frame. Yeah, and there's actually Spark, I've seen this question come in a few different forms, so let me find the GitHub. Off of TensorFlow GitHub, there's something called ecosystem. Here's a link. So this is really more of a TensorFlow question. And in here, you're going to see ways to convert between Spark. And so TensorFlow really, for all the stuff that we see, this is something I still haven't mentioned. Like we'll get to it here in a bit. But when we're in TFX land, we're really trying, or it's way more preferable to be using like native TensorFlow data formats. And that's TF example, which I mentioned earlier, which is really a row. And that's based on TF record. And so TF record is a file format that in Spark land would be most similar to something like Parquet or Avro, right? And so this like ecosystem project that I sent there gives you the ways to convert between TF record and Parquet and back and forth between the two. Airflow is free, yes. Can TensorFlow DV work with Parquet? So not natively, and that was a perfectly timed question there, because TF-DV really wants TF record. Now, and I want to make it clear that what we're showing today is ways to use these libraries as they were intended to be used. There's no reason that you can't go and implement your own data validation. It's just, if you don't use TF record and you're not using the full capacity of TensorFlow data validation library, you won't get the nice, pretty visualizations that let you slice and dice the data and look at different facets of the data. Airflow is free, yes. Dataflow, yeah, that's the Google implementation of Apache Beam. Okay, data prep, trifecta, okay. Looking at some more questions here. Kubernetes between Kafka is, you would have to build that custom. And essentially you'd be using, if you're in Python land, you'd be using Kafka streams to listen on that stream and then do your munging, make your prediction, and then, so really it would be a combination of either Kafka with the C library, yeah, so let's step away from C and just talk Python. It would be Kafka streams written in Python, the Kafka streams Python adapter that can read the stream from Python. It would call into TensorFlow from Python, make a prediction, and then use Kafka streams to put, or the Kafka client to put the data onto the output stream. Yeah, okay, Harold. Yeah, thanks for the clarification. Google Cloud does not offer Kafka. They have PubSub and Event Hub. Supports Kafka APIs. Okay, cool. Okay, so Pablo reports a blank cells on Safari works fine in Chrome. Pablo, one thing we found with Chrome anyway was in some cases we had to refresh the browser. So maybe, so I see it's working fine in Chrome. Maybe in Safari, if you try to refresh, which maybe you already have, I don't know. Yeah, we have very little Safari users. Oh, and then Firefox, it's blank as well. Yeah, that's interesting. For the ones that are blank for Safari and for Firefox, can you guys give us any hints as to, if you install developer tools, show us if there's any errors in the JavaScript or anything? That would be helpful. Okay, there's a detailed question here on same idea for challenger models. Yeah, so the question from Steph is more of a, let me think. You could do all of the things that you're saying here, which is you can do basic, random, priors. These are, like much larger sort of A/B testing. There's also the concept, which I think you're hinting at a little bit about. There's this concept of swim lanes when you're really dealing with A/B tests, where you are going to enter situations where someone else's A/B test is affecting your A/B test. And this is the hardest problem within A/B testing. The thing about the mods for even numbers, and everyone tends to pick even numbers, I don't quite understand, because customer ID is being random, or is essentially not being chosen by the user. So maybe I'm misunderstanding that, but yeah, maybe we can talk about that one offline. I don't know how to expose so the way that these things work, this complex JavaScript voodoo in these notebooks, is it's JavaScript, and it's literally it's utilizing the fact that these notebooks let you embed your own JavaScript. And it's just, it's basically acting as a complex web app within your browser, or within your Jupyter cell. So we'll see in a little bit how we can expose other things through ports. We'll do TensorFlow serving, and actually TensorBoard as well too. Oh, nice. Okay, so someone found a, yeah, thanks, VJ. Found a GitHub issue that these visualizations only work in Chrome. Okay, can we iterate through TF records? When Spark data frames are written to TF records, and how do we iterate through those TF records? Yeah, so these libraries, like the TensorFlow data validation, operate on TF records. So once you convert them into TF records, then you pass it into, so typically, I think maybe what you're getting at here is, once you convert them, you have to store them somewhere, and then you point the library to where you store the TF records. So one thing we get asked all the time is, well, can I use TensorFlow within my Spark job? And you can, and that way you get the data partitioning, and the, just as long as you have TensorFlow installed on all the machines, just like you would install scikit-learn on all the worker nodes for your Spark cluster. But what we tend to encourage is to keep those clusters separate. This is something that we've kind of learned empirically. In theory, it's nice to combine all these technologies into one cluster. In reality, they all have their own kind of monitoring, their own cluster characteristics. And when you start to try to combine everything into one, if you're trying to do distributed TensorFlow using a Spark cluster scheduler, things get all crazy. So what we like to do is have a separate cluster for all your Spark activity. When you're done with the feature engineering, you write that data using the converter out to TF record, and that's in some S3 bucket or some shared file system somewhere. And then your TensorFlow job, and specifically data validation, probably pipeline kicks in, reads those TF records off of the file system, and then processes them. Yes, without storing them. Yeah. So again, the only way to do that without storing them would be to use streams, which essentially is storing them. It's just storing them kind of transparently from you. Yeah, so we'll go through the exercises and see where TF record comes in. All right, it's 11:15, which I think was the time we were going to resume. Yeah, okay.
We do have more questions in the Q&A panel if you just want to have a quick look. Or...
Can you share TFX papers? Yes. TFX white paper. Getting the TFX white paper here, which I'll post it in the chat for everyone. That's a really good one. I actually read it on the plane about a year ago, yeah, a year and a half ago. And yeah, I took a bunch of notes somewhere. Can't really find them. Okay, so Andrew's asking in the Q&A section about model interpretability. And this is a really, really good question. This is actually a huge field or subfield within machine learning is interpretations, explanations. This is very, very important to a lot of people for a lot of machine learning use cases. It's not always the easiest thing to answer. This interpretability of models is one of the single largest inhibitors to the expansion of neural networks and potentially all of machine learning. Well, so like said differently, there are places and countries and portions of the world that will not use models if they can't be explained. And neural networks tend to fall into that sort of mystery world, which is unfortunate. So one cool thing about convolutional neural networks, despite what like many people think, is convolutional neural networks that are used very heavily with like image processing and image classification are very explainable. You can print, sort of visualize, and you've probably seen, pictures of this where you could see what each layer has learned. And so convolutional neural networks actually are fairly explainable. Natural language processing has, there's ways where you can show the like word embeddings and the new set of dimensions and like axes for terms that have been learned. And let's see, how do I say this? So and with traditional machine learning, especially linear models, right? Like linear regression, logistic regression, these are all very explainable models. This is why a lot of machine learning practitioners tend to fall back on non-neural network, just sort of traditional like machine learning, because it is very explainable. And I'm starting to see this pop up in apps and websites. I just downloaded an app the other day called Bands in Town. I have no affiliation with them, but I'm just so frustrated with San Francisco music scene. I can't seem to get any country music out here, and so I installed an app to notify me whenever country artists come in. And the app asked to scan my entire Apple Music collection, which I somehow accidentally clicked yes. And all of a sudden, it was making recommendations as to artists that were coming in and telling me why they recommend this. It's because you like this person and that person. They're coming into town next week. So that was a case where I was actually kind of happy that I clicked yes and inspect all of my music collection. So the short answer, I think this was Andrew, yeah, is if you stick with like linear models, this is much, much easier. But when you start getting into some of the advanced neural networks, there's quite a bit of like voodoo going on. Fortunately, humans can look at layers of a convolutional neural network and make sense of it and see that this particular so this particular neuron learned this particular edge or this shape of an eye or ear, something like that. So, but there's quite a bit. And in fact, I thought I have a notebook somewhere. Let me actually get a link to a library. Actually, I'll just send you guys the link to the library. It's a Keras. Yes. Okay. Oh, okay. Here's a project for interpretability. Yeah. Who's my favorite country? Oh, Jason, you're funny. Here is a link to a TensorFlow Keras friendly open source project for explainability. And if you follow some of the links there, there's some really good blog posts. One of my buddies is the creator of this. He has spoken at, I think there's an O'Reilly blog post on it. There's a couple talks with O'Reilly. Okay, so link to, do I have horses in the back? I didn't think the country music thing was gonna cause so much comments here. Okay, can you use TF modules to train, validate, and deploy scikit? Yeah. So the question is about how friendly is TFX to non-TensorFlow. I would strongly encourage, so like I said, there's nothing stopping you from implementing your own components that bypass a lot of the value of TFX and these visualizations and use other file formats. It's definitely a great place to start. Before we get too much into TFX, let's take a look at KubeFlow here in a bit and kind of get us out of thinking too much TensorFlow. And we'll show an example using XGBoost. We'll show some scikit-learn examples and kind of get us thinking. But the short answer is you can build any TFX component that you want that does anything. But for the most part, to gain all the value, and you will certainly need to stick with like TF record and stuff for now. Okay. Concepts like Lime, yes. So actually, the link I sent, Skater, uses Lime. I believe there might also be an alternate implementation for, there's another algorithm. If anyone can remember the other algorithm besides Lime, there's one that's supposed to be a little bit better. The name of the app is Bands in Town, like rock band, band in town, bands in town. Can linear models follow a similar process of learning for TensorFlow? Yeah. And in fact, one thing so the question is about, can we just use regular linear models with TensorFlow? Absolutely. In fact, when I was first learning TensorFlow, one of the most valuable tutorials that I was reviewing was implementing linear regression with TensorFlow. And this completely blew my mind because all the prior examples I've been learning were all these crazy convolutional neural nets and recurrent neural nets, when all I really wanted to see was how do I create a variable within TensorFlow? Yeah, how do I execute my DAG, my execution graph within TensorFlow? And yeah, how do I get the outputs? And so you can certainly, and in fact, TensorFlow has a version of gradient boosted trees that they claim actually outperforms XGBoost in certain cases. So yeah, there used to be a project called scikit-flow or skflow that was a literally drop-in replacement for scikit-learn, but using TensorFlow. But I think that's actually been like rolled in, and it's now basically part of core TensorFlow. All right, another, yeah, line can build. Yeah, actually, so Steph pointed it out there. Yep, yeah, these are the exact like examples I was looking at. That's awesome. There are boosted trees in TensorFlow. Yep. Stephen, you're silly. Okay. Yeah, I think is it Shapely? I think that's what it is. Or Shap, yeah, Shape. Okay, so people are getting concerned that we're only at number 2. Yeah, I agree. Okay, Shapely. Okay, so let's get moving here. Oh, there's another question here. Does validation? Okay, that one I already answered. Okay, let's train models in real time. Okay, so yeah, Honorud is asking about training models in real time. Currently, would I pick the last 10 hours and use in the next week again? Yeah. So online trainings, this is pretty much how people do it the way that you described it in the Q&A. Newly trained model, repeat this. It's sort of discrete continuous training. And what you're doing by picking the last 10 hours is sort of naturally favoring newer data and, you know, kind of decaying older data. So yeah, there's quite a bit, there's quite a few techniques to do this. Do you recommend using TensorFlow data sets? Yeah, TensorFlow data sets. So actually, TensorFlow data sets is kind of an interesting name. I always have to double check and see what the context is. TensorFlow data is what you would use to do the processing. TensorFlow data sets is literally data sets. So I think if the question is, do I want to use an already curated data set, then the answer is yes, absolutely. If the question is, how do I process my data, do I use tf.data? And the answer is yes, of course. If you don't, or yes, I would certainly use tf.data, because if you start to do it on your own, you're going to miss out on a lot of the parallelism and concurrency right. So think of how Spark does it. When you are reading in Spark data, it's pulling in from multiple partitions in parallel, and it's operating, it's joining, it's mapping, reducing. When you use TF data, the same type of thing is happening in parallel. And really, when you use things like S3 or Google Cloud Storage as the underlying data store, while these are perceived as slow, what you're actually doing is pulling in parallel from a distributed file system that is being managed by Google or like Amazon. So there's lots of parallelism that you'd be missing out on. There was a brief point in time when TensorFlow had something called queues that was kind of the hacky version of doing parallel data ingest and transformations, but yeah. Okay, so I think I answered all that. Let's get to, so let me look at the TensorFlow data validation. Notebook here, TF data validation. Okay, so this is really just giving you a peek. Let me run all here. Oh, actually, I trust this, be a good citizen. Restart that. Okay, so hopefully this made sense, talking about distribution skew. Mentioned there about the serving and training aspects. Okay. So hopefully this made sense. I'm going to keep moving on for the sake of time. Okay, picture. Coming from the GCP world, but my jobs. Okay. Yeah. All right. So I think that one was pretty straightforward. So let's keep moving here. So here's a bit on the libraries. And I think this will be the last section. Then we're going to take a lunch break. And let's see. TensorFlow transform, pre-processing the examples, TF record, full path. So this is where you can, of course, calculate mean, standard deviation. You could also create sort of string to index. And this is very common when you're working with textual data. And then also bucketizing. So you could take a look at the overall distribution for a particular column of your data. And then you can either bucketize, you can like normalize, do whatever you need to do. And try like various things as well too. So you don't necessarily have to stick with one way. You would create multiple models using different bucketization values. You know, these are basically hyperparameters into your system, but expressed through feature engineering. This is going to output a tensor. So this is the key here, is this TFT, which was actually introduced about 1.5 years ago, and no one really knew what to do with it because the overall TFX had not yet been released or rather well expressed. So, but you can actually reuse this little snippet, this graph, across both training and serving. And so this is where we start to see a need to have something like TensorFlow Hub, which is this kind of catalog of graphs or models. But you know, maybe like we don't really want to or maybe we just want little snippets of graphs. And so so TFX doesn't really support this. I guess the closest thing would be storing this graph in the metadata store and then storing the graph, you know, in some file system or S3 bucket somewhere. But the idea is that you have this graph that can transform the exact same way during prediction time that you did during training time. And so this is very important because if you start to do things differently at serving time, or if you don't transform at serving time, but you did at training time, you'll get wildly crazy like predictions and sometimes not even know what's going on. And it's because data from the wild is coming in just as you know, odd as data that you use to train. And you know, hopefully they're from the same source or similar, and you can transform them the same way before that data gets to the model. We'll be seeing Beam talked about here and there. You might see some warning messages. This is really, think of it, you know, in a local environment, think of it just as a way to do things in parallel and to stream this data and not have to store it all in memory. You could also run it in distributed mode, which we're not really doing here. We're running in kind of local single node mode. The key method to implement is this pre-processing_fn. You'll see this in every bit of TFT code. And here's an example where we're scaling between 0 and 1. And that should be in this hands-on here as well too. So I think this one's pretty straightforward. Go back to 3. We're going to show a very simple one. So this is the one right out of the example that I cut and paste there. And let this run, and this is all that's happening here. So this Beam context, as much as possible for now, yeah, I would just kind of consider the Beam to be black box. It's just pulling in the data. You know, it's using all these wonky temp directories and stuff. Just kind of forget about that. Let's focus more on what's conceptually happening. So here, analyze, transform. Here's the pre-processing function that we defined above this thing. Scaling it, centering it, normalizing it. And let's see, raw data transform. And then there's the output here. Okay. All right. So TF model analysis. I think, is this the next? Let me just double check. Yeah, that's 04. Okay. So model analysis, so analyzing the model on different slices of data. So this is what I was saying earlier, which is we could, so once the 04, this notebook runs, so this is the one that Antje and I have had the most trouble in preparation for this workshop. It's because this particular, so this notebook is installing custom extensions for Jupyter, kind of requires a restart of the Jupyter kernel. You might have to refresh your browser. Yeah, so like we can do that all together here in a bit, and that's how we'll end for the break. And then you could play around with it and slice and dice all you want. But this is at a high level what's happening here. We're going to analyze this model on different subsets of data, right? So again, we've got a model. We're now going to pretend as though we are only passing in different slices. This is actually based on the Facets project, which was posted by Google. There was a blog post on it maybe 2 years ago, and people got all excited, but no one could really figure out how to use it or where it fit in, or couldn't stabilize it. So now it is being expressed as part of TFX. You could do things like the next day, so you would like deploy the model, for example, and then next day kind of go and look and see what, so like there's ways to sort of track these metrics over time. So you would see like how the model is doing today, you would then simulate, how is it going to do tomorrow? How did it do 2 days ago? You can kind of travel on time. So this is pretty slick. So if you're familiar with TensorFlow has a saved model format, there's this format called the eval saved model that actually contains this extra info to handle the slicing. So, and the overall pipeline here is it's going to read, it's going to extract, it's going to evaluate. And this is really a way that, primary use I've seen this for is to make sure that this model is fair across like various slices. If we start seeing wild like results on specific subsets of users, sort of row-wise slicing, right, like slicing by rows of data, then we have trouble. All right, so let's try to get this to go here. Yeah, and Antje's going to keep an eye. I think the best way to do oh, and there's an O3 transform advanced. Sorry, I missed this one. Oh, this is actually, so the reason why this is kind of subset A here, subscript A, is it's straying from the taxi data set, but I did want to show this as a sort of like more advanced example. This is our friendly census data. We're splitting categorical numeric features and optional features. So that's why this is a pretty cool data set for this, because TensorFlow distinguishes between categorical, numeric, well, yeah, all machine learning does pretty much. But there's first-class support for categorical, numeric, and then optional fields. Okay, here's some hyperparameters. So we're cleaning the data. So again, this is a little bit more beam than we would like. This is the current state of things. Here's our more complex pre-processing _FN. Scaling, building a vocabulary of our categorical features, and then doing lookups here, transforming the data. And so this is where it's reusing, make serving input function, transformed output, the same graph, that our data into feature columns. Feature column is this first-class citizen within TensorFlow that's kind of related to TF record. Yes, I have a whole talk on this from, I think, last year sometime, but feature columns, and there's like different types. There's ways to cross features, which is a very valuable concept in machine learning. So don't just look at age, but also look at combined age and income. Is that a feature to combine these things? And what we're getting to here is different ways to create a schema and to validate the schema during this. So this is evaluating, it's doing a whole lot of stuff here, transforming and training. Pre-process the data, train a model. We use the same code for both training and inference. We avoid any issues with data skew, creating an Apache Beam transform. Small piece of wood, yeah. So pretty cool stuff there. So what I would recommend here is to go in and make sure all of the notebooks are shut down. So all these, the green should go away. I like to refresh my browser every now and then. And let's get into 04 here. So we did a little blurb on it. Okay, so this is the one that we have to be very careful. Have to click not trusted. So we do want to trust it. That's going to do some refresh. We're going to, I'm just going to show you guys how to get this working, and then we're going to take a break, and then I'll answer some questions, and you guys can read through this. Yeah, do this for like maybe the next 45 minutes or so. We'll probably come back at 12:30, and there's a lot of very, very useful stuff in here. So make sure this extension gets set up. Oops, I don't know why it's downloading something. That's weird. I'm supposed to do that. So once this is installed, I would refresh your browser. It's kind of like praying to the demo gods here, except times 100 people. And then start back from here. So you actually don't have to reinstall this. You could start from back here again. So it's trusted up here. One thing I personally do when I'm on this notebook in particular is I keep an eye on my developer tools just to see if anything funky is going on. Close this. But for the most part, I think with the trusting and then the refresh, pulling down some data. So the success criteria for this particular notebook is we're going to get to a point where we can render these slices and start to analyze them right directly inside of Jupyter. If you guys are like having problems getting this to go, so this is one of those that takes a long time to load. Okay, so the first visualization that you should see, so again, success criteria here would be this cell shows slices overview, histograms. So this is an interactive, yeah, so just ignore this as one of those OCD ones you can ignore. Python Snappy is not as fast as it could be, that's fine. And we could start to look at the start time and the end time of this trip. So the goal, yeah, so stepping back, by the way, this data set, the model that we're building is we're trying to predict the tip based on the characteristics of this taxi ride. Okay, so if you can't see this visualization, if it's taking a long time, refresh your browser, make sure this is trusted, restart the kernel. What happens is we've installed something that the browser needs, and the kernel needs to be aware of it. And so depending on, so we've seen different errors with different environments, but again, this is like, this is the most complicated notebook that we'll see in terms of this flakiness. So once we get past this one, and you guys study this really during the lunch break, then we'll be in good shape for the afternoon. Things will be smooth sailing. Yeah, Ansha, how's everyone doing on the thing? Can people get to this?
So far, I think yes. So again, Chris is giving you a quick introduction. Feel free to run the notebooks at your pace and read through them. Let us know if you have any questions. There was one question, Chris, to be able to run today's notebooks, like on a personal environment, what needs to be set up on top of Anaconda, assuming there is a Kubernetes cluster already, to kind of reproduce the environment?
Yeah, let me point you guys directly. So everything is in this, this GitHub repo. And you can even see it from your notebooks since you guys cloned it. So actually, let me go back to my notebooks and show. So here I'm going to click KubeFlow TFX workspace. Going to click on infrastructure. And here's a user data, which is kind of a Linuxy term for boot script or start script. And this is the exact start script that we're using. So if you really want to get deep down into the bowels of all the Linux commands that were in action here, there is a pipeline CLI command that we have that actually does some of the installation. So I can certainly point you in more direction there, but this is all the nasty Kubernetes. And if you already have Kubernetes set up, you would then start from basically this point. You would create the namespace and follow this. So I think between you and your ops folks, you could look at this and figure out what needs to be done. Is that the answer, or is that cool?
Yes, perfect. Thanks. So there are a couple of questions in the Q&A panel, Chris, if you want to have a quick look.
Yeah, I'm looking right now. Their format data is for it to load into TFX. So the CSV will be parsed and then converted into a schema. So someone's asking about data.csv. Data.csv can be in any format as long as you build the parsing code to then pass TFX to generate. Transferring TF tensor size. Right. So Thomas is asking Keras text import tokenizer. Yeah, Thomas is asking. So he's got some scikit-learn preprocessing, got label encoder, and text tokenizer. I don't know of an easy way to do that in the preprocessing step besides hacking through it. That's something that we're keeping a close eye on to see, how much Keras support. Right now, like I said, TFX is not very TensorFlow 2.0 compatible, and it's still a bit TensorFlow specific and not necessarily friendly with Keras either. But yeah, I do feel the pain there. Yeah, Steph's asking, can the schema from validation work be used programmatically transform? Yeah, the recoding in TFT does seem a little bit wasteful, and I don't have a really good answer on that. So typically we start with these samples, right? Just like anyone would. You start with a sample and you just try to adapt your code as close as possible and not stray too far. So that's a great question. I just don't have a very good answer for it. So I think the sort of larger question here that I think we're all starting to see is there's a lot of code and there's a lot of boilerplate, right, that's involved here. And in some cases, it seems like we're just writing code for the sake of writing code and to use these libraries. So for some lesser experience, like machine learning practitioners, this might seem like total chaos and craziness. But there are really good things, and the slicing, these visualizations here, do sort of highlight for the more experienced practitioners. And some of you, like the question I was just addressing, are realizing that there's better ways to do these things, right? And so why are we writing all this code to do it? That's just the current state of things. And so just wait till you get to the KubeFlow stuff this afternoon, where you don't even see the code. It's a Docker image that someone else wrote that you have to track down. So my point here is, while we all want to love KubeFlow, there's still quite a bit of voodoo. And at least here I can see the libraries that are being used. And at least Airflow plus TFX, I kind of get it. Like I can go in and, debug this code. And, yeah, oftentimes with KubeFlow, there's quite a lot of sauce, like secret sauce going on. Okay, TensorFlow with PyTorch on MXNet. Yeah, this question comes up quite a bit. You make a technical decision. So yeah, these are questions that are hard to answer without knowing more about what the company and team is doing. General rule of thumb, TensorFlow is good for images. PyTorch is good for text. Those two are coming closer to each other. So PyTorch is getting better with images. TensorFlow is really coming on strong with text and starting to, so like typically when, if you're sitting down and it's a green field, people choose PyTorch because of its text processing and its NLP. The problem that they run into quickly is there's probably, in my experience, I'd say there's 10% people using PyTorch, 90% using TensorFlow. That's sort of overall. That's a bit skewed because a lot of what we're doing is sort of image, is rightly geared more towards images. So, take it for like what it's worth. What my point is if you enter somewhere where the community is not as large, you will end up in corners, in these corner cases that you can't get out of. So our recommendation is start with TensorFlow, see how far you can get. There's a very, very high chance that you will end up somewhere that someone else has already solved. Also, the other cool thing about TensorFlow is a lot of papers that are coming out have TensorFlow that's already implemented. They have versions, so people are no longer just releasing papers, but they're actually releasing papers with an implementation. And in most cases, that's TensorFlow. Now, again, I love PyTorch. Very, very well received. Has a great serving runtime, which is Cafe. They've now merged Cafe with PyTorch, and they're essentially the same thing now. Cafe is more of being seen as the TensorFlow serving, more of the actual prediction engine for PyTorch models. But yeah, it's hard to say which one's best for your team without actually knowing what you're doing. Let's see. I don't know anyone using MXNet, honestly, outside of Amazon. Chainer is big in Japan, I think. But that's about all. I don't see too much of those. Let's fall back. So what do you do if the inference data distribution is not the same as training? You have big problems. You have to retrain. So this is the whole reason that you want to detect this. If you don't detect this, you will go many, many days, hours, months, weeks with bad predictions. And this is the whole point of, and these are exposing more of the advanced pipeline type of problems to solve. If you built a model and pushed it out and haven't actually analyzed it in months, there's a very good chance that your data distribution has changed, and it's time to go retrain. That's really the only thing you can do is then retrain. When you say Beam is doing parallel, is doing multiple data containers, just for our purpose, Beam is doing parallel processing in multiple processes. Correct. we're using the local version. Yeah, so that's, so Jeff is saying, love how fast it's giving me an initial look of data. Is there a way to do this at scale? The idea here is that this should scale. This is where so this is where some of the limitations of the browser will start to kick in. So Facets is a project on its own that's been rolled into TFX. Well, I guess said differently, Facets was always part of TFX, but Google carved it out and pushed it out as Facets. And I never actually used the original one at scale or with anything beyond just simple toy models. So the question about can I use Facets and this particular notebook with larger data sets, this is where, let's see, it's, at this point, it's mostly browser limitations. Let me look at the notebook again here. Yeah, I'm just looking to see if there's any Beam stuff that's exposed here. Yeah, I mean, give it a try. And yeah, I would love to hear the concept of TF records. The combination of TF records and Beam is supposed to give you that scale, but I have a feeling that is the ideal situation and not the reality. Yeah, talking many terabytes of data. Yeah, exactly. Yeah, that's a good question. Let me take some time to actually look into that.
And we have one more, Chris.
Okay.
Keras with TensorFlow backend. Is it workable in TFE?
So TFE, I assume, is TFX. Is that okay? Where is this? Oh, okay.
In the chat, yeah.
Yep. Oh, this is okay. Good. This is the visualization only works if you did not run any pip install after you start a new kernel. Oh, great. Okay, that's good to know. Although I think I ran pip install after I started the new kernel. Yeah, I don't know. We've had so many theories this week on why this notebook is misbehaving, down to clearing our browsers and all kinds of crappy solutions. Okay, is Keras workable in TF? Okay, Keras with TensorFlow backend. So, yes. So the short answer is Keras can, and so there's two answers to this question, or there's two sides to it. So first of all, Keras is now part of TensorFlow, and Keras becomes a library of TensorFlow. Saying Keras with TensorFlow backend is how things used to be, and still are. Like you could still use Keras with, I think, well, yeah, I mean, Piano's gone, but so these days when people talk about Keras, they're speaking of it as just another high-level library within TensorFlow. Okay, so that said, can I use TensorFlow, or can I use Keras libraries within TFE, or yeah, like TFX? And the answer is yes. We don't have any examples. I was hoping that there would be a 2.0 example, because in TensorFlow 2.0, Keras is the preferred API. I very quickly realized that there are no examples and that TFX has problems with TF 2.0. So the short answer is I'm 95% sure that this works, but I would be 100% sure if I could have gotten the TensorFlow 2.0 stuff working with TFX. So the 95% of me says there is no reason why this shouldn't work. Keras is just like using NumPy within, right, like TFX, which we're using NumPy, and yes, we're using all sorts of things in these notebooks. The other, I guess the third response to this is Keras with TensorFlow can support TF record, and so therefore you gain all the benefits of these visualizations. So we should do some type of data validation transform before one can do inferencing, right? For model building, that is more done batch, but for inference, it's streamlined and done in very small batches. Yes, so Teresa asked a really good question. We're all very familiar with feature engineering in batch and during training when we have all the time in the world. Her question is, how does this work during sort of real-time inferencing? And yeah, you hit it right on the head there, which is we need that snippet of code which is generated by one of the earlier steps to make those transformations during both. So basically, your simple sort of inference code that takes in a JSON request or something and calls the model, right, like converts it into a tensor or NumPy array and calls into TensorFlow, now has to have this extra snippet of code that will do the normalization, standardization, and do that similar feature engineering. So I think the intuition that is implied here is at batch, at training time, we have all the time in the world. During inference, we have millisecond. So how does that happen? And yeah, I think Teresa points it out, which is these are smaller batches of data coming in during inference, or you have to figure something else out. The other piece of intuition I want to highlight here is the more you can push into your TensorFlow model, so the more TensorFlow native transformations you can make, the better. And it's the exact same concept with Spark, where the more you can utilize Spark libraries and push into Spark, the faster your data processing becomes. And this is because Spark can optimize Spark things, but Spark can't optimize outside libraries that it doesn't know what to do with. And same with TensorFlow. So like before TFT came along, where it could actually generate this snippet of like this TensorFlow graph that I could reuse, people did all kinds of crazy things. They were basically building their own UDFs. That's what they're called in Hadoop and database processing and in Spark. And TensorFlow didn't know how to optimize these things, right? Like just like Spark doesn't know how to optimize outside code. So the more you can push into the TensorFlow graph, now TensorFlow can rearrange it and optimize it, and like apply XLA, accelerated linear algebra, and can optimize it for GPUs and make it distributed, right? And yeah, do all the fun stuff there. Okay, so yeah, good question, Jason. Let's do, it's 12:05. Let's come back at 12:45 p.m. PT. And I'm going to rest my throat here and grab a quick bite around the corner at the coffee shop. So I'll see you guys in about 40 minutes. Okay, let's finish off here, TFX libraries. So quick overview here, TFDV, TFT, TFMA, and TF metadata. So we talked about this. We talked about TFT. Talked about model analysis. And I think there was a question, yeah, if there's slices that are beyond a certain, that are showing accuracy or, poor accuracy, then that's a sign that you want to get more training data in that area and try to retrain and get some better predictions there. Okay. So metadata, yeah, this is, I think we went through this a little bit. This is storing data between the components in a run and artifact lineage info. If there's one area I would expect folks like Pachyderm and that are looking to specialize in this kind of lineage tracking and reproducible experimentation, I would certainly be paying attention to what's going on here, because my gut feeling is, well, well, there's two gut feelings here. The first gut feeling is this is just the start of what Google's releasing. The downside of this is my feeling is they're going to make whatever really robust solution specific only to Google Cloud, which works to their advantage, but not necessarily to all the Amazon users and things throughout the world. Okay. So third section is TFX components. So this is where, there's that magic Slack one over there, 2.3.10. I think I have some code that shows what's going on in there. But these other ones are ones that we'll see in the Airflow, which we're going to do next. We're going to actually launch the DAG if you guys haven't already. So these are all the same ones that we saw in this diagram. So the example gen, this is loading data into the TFX pipeline, supports external data sources. CSV, if you can, use TF record or at least get into the habit of converting from CSV into TF record. And while it is difficult to use non-TensorFlow models like XGBoost, it still can be done. It's just you'll need to get things into TF record to start to actually gain some of the usefulness here. So, all right, statistics gen. And yeah, this is just what they're called. This is the names of the actual components. So the example gen was generating examples or generating training data. Statistics gen is generating statistics on the training data. And we talked about that a little bit. Schema gen, generating a schema from the training data. This is anything optional, required, consumes data from statistics gen. And this will auto-generate the schema.proto. So proto is protobuf from the training data. And this schema is used downstream in the feature transformation and data validation. So it's best effort, it's basic. The idea here is you should be hand reviewing this when it's done. And let's see, let's keep going here. Example validator. So this is on the data side. So we still haven't yet trained the model. Identify anomalies. Spend plenty of time talking about that. So transforming. So again, it seems like we've already talked about a lot of this, and I'm showing two different views of, so this is at the component level. And if you recall in an earlier slide, I said components are made up of, or you build components with these underlying libraries that we discussed, the TM, DV, TM, and then TFT. So here's transform. And PCA, feature crossing, very important. So this is the actual training. Produce a save model and the eval save model, which is what we're going to use for the model validator step when we do the slicing and dicing. Okay, TensorFlow 2.0, yeah. So native TensorFlow 2.0 Keras support is coming soon. So the evaluator uses the special eval save model. And it, of course, writes all the analysis to the ML metastore. And so this is where the scale comes into play. So yeah, this is what I was mentioning before, where the default answer by Google will be to use Apache Beam and use their distributed data flow product to perform this at scale. Okay. And so this is where we can actually start to introduce a little bit of human in the loop, or if we want to, automation to say if the new model exceeds or meets a particular metric, we can mark it as good to push. If not, we could send it to Slack, or we could always have the human in the loop. But all the results, of course, end up back in this metastore. And yeah, we're going to take apart the metastore here in a little bit in one of the notebooks. Okay. And model pusher, this is storing these. So we're giving it the the directory to write out the saved model, which is then going to be used by TensorFlow serving or your Python Flask app to slurp in and start to serve. So here's the fun Slack component that a lot of people, including myself, get excited about. So after the model is validated, it would send to the Slack channel. If you're familiar with the Slack API, you have to create these auth tokens. Here's the actual code for it, but here's kind of a snippet. You have to obviously give it some channel ID, give it the secret Slack token. This works with the bot token down here. And you're passing it URLs and things so that the person, the human, can actually click and go straight into TFX and see these results themselves. I'll click, and you can respond LGTM, approve, decline, or reject. All right. So Airflow and KubeFlow. So these are the two. It's been very obvious that Airflow is the one that is either being used internally or the most similar to what's being used internally by TFX. This has the most support. Bugs get fixed here super quickly. KubeFlow TFX seems like it's a separate community. There's cross examples between TFX and KubeFlow, but it's not quite sure who actually supports what. In fact, I'm on both Google groups. There's a KubeFlow discuss, I think, and a TFX discuss. And oftentimes when I'm posting questions, I don't know which group to post to, if I post to KubeFlow or TFX. But so it's a little bit of confusion there. But you see that the Airflow one follows almost exactly one for one what you see in the TFX configuration. So that's likely not a coincidence. And here, KubeFlow has kind of different names for things, but still getting the job done here. It's transforming, it's doing data validation, it's doing model analysis, and then generating metrics, and doing the training. Also, the bottom right there, or not bottom right, but the bottom right of the bottom left, it says KubeFlow serve. That's actually generating the Docker image. And then also starting the TensorFlow serving server. All right, there's something called TF operator, or TF job is often how it's referred to. So we'll get more into detail in that, the bottom right there, but we'll actually kick one off and see it working. So benefits of Airflow. Everyone uses it. If you haven't used it, you're likely not doing anything super complex. I hate to say it. The more you move off your laptop, and if you have your own local Jupyter, or your own local way of orchestrating with some bash scripts, that very quickly breaks down. So tools like Airflow have been around for quite a long time. Airflow is Apache. In my personal experience and just seeing the community here in San Francisco, there hasn't been a whole lot of innovation with Airflow in the last couple of years. One big thing recently is it supports Kubernetes, but that even took a very long time. So the person who created Airflow has left, actually joined Lyft for a little bit, and now has moved on to their own company, focusing on his more recent project called Superset, which is data visualization, kind of like Tableau, but a bit more, I guess, modern, you would say, a bit more Spark native and big data native. Supports Presto and all that as well. So the short of it here is Airflow is very widely used. There's a lot of little patches out there that people cobble together. The good news about Airflow is you can run everything in Python, which is data science friendly. Whereas in KubeFlow land, the current state of affairs is you're building a lot of one-off bash scripts to generate Docker images, to hook up, to pipe data back and forth. All right, and then, so decent UI, good community support. You can pretty much find things, someone's patch that works for what you need. The downside is, so while it's an Apache project, it appears to me anyway, this is my personal opinion, that there really isn't anyone central behind Airflow anymore, which I guess is kind of the idea of going Apache. But at like one point, it was very much Airbnb. Airbnb has forked it and essentially has their own internal version that's been heavily customized. One downside with Airflow is that there's really no edit sort of interface. You're never actually updating anything directly in Airflow. It's more read-only. It's just looking at the graph and seeing where the graph is in its sort of execution phase. So one very common frustration is people want sort of one place to go. Well, there is a code button over there that's just a read-only link, and it just shows you the code that's currently executing. So you still very much have to comply with and put things in the Airflow DAGs directory and some other stuff. All right, so let's do this. So 05, I'm going to pull it up. Before I pull it up, I'm going to go back to notebooks here and shut down what I was running before. Okay, and so again, make sure, go back to your main menu over here, go to Airflow, and again, make sure this particular thing right here has been unpaused. And again, this is something that you would normally script, but I just didn't make it into the final cut for this. So if the reason that you have to unpause this is when we click play right now, which what we're going to do right now, click play to trigger this DAG. If it's on off, that means nothing's going to happen until we unpause it. So by default, these DAGs come up paused. All right, so next thing that you want to do is click into this DAG. So click the play button over there, or you could click into it and click trigger once you get in there. Click on the graph view. So again, starting with DAGs, make sure that's on. Click the DAG, click on graph view right here, and you should start seeing stuff happening. So you can click on an individual component, you can view the logs, it's telling you what parts it's running. Go back to graph view. So we'll let this run for a little bit. And let me go back here. Before we can do 06 and 07, we have to wait for 05 to finish running. So rather than just kind of sit here and twiddle our thumbs, well, actually, we can click here and we should be able to look at the code. So if we click code, so this is one monstrous, oh, it's not too big, I guess. Yeah, I don't know why I thought this was bigger. It seemed bigger at the time when I first was looking at this. So here's a create pipeline. This is actually just kind of a convention here. Really, so to kind of summarize Airflow, it's taking whatever Python that you feed it, and it's going to run it. And Airflow itself is a set of Python libraries. And let me see. So this Airflow DAG runner is actually part of, it's a Python library that takes in this Airflow configuration that's been defined up above, and then can run pipelines. So really not, it's kind of, seems kind of silly, but it's a standard that like everybody uses. These components all, extend or know how to log to Airflow, and that's all the nice stuff here. So here's, so we would have to go look these up sort of individually. If you notice, these fall under TFX components. And example gen, so again, this isn't like a demo example. This is like a machine learning row being passed into training, or as training data, rows of data. So each element is called an example, each observation. So don't get thrown off by the example thing. And And then model validator. So if you want to, you can go, click around and actually look at this code. Oh, and so, right, okay. So the Airflow DAG runner is actually part of TFX, but this is actually implementing Airflow specific constructs underneath. So we're basically doing all the things that we have been doing kind of manually, except now we're doing it within Airflow. Let's take a quick look at the DAG. So here it's chugging along, it's going to do that. It's going to then validate the examples. So this is kind of cool. It's able to do the example validation and the transformation. It could actually do these in parallel and only stop this pipeline if the example validator finds something wrong. But in the meantime, it's going to be optimistic, continue to transform, pipe it into training, and then use the evaluator, and then ultimately push it out. Okay. So let's do these in a bit. I'm going to jump ahead to the KubeFlow stuff here real quick. So like I said, KubeFlow basically wasn't really much to us until pipelines came out. We had been looking at either extending Airflow or we obviously knew about TFX, but knew that it was based on Airflow. So we were kind of waiting. We caught wind of KubeFlow right when it first came out. We had heard about some pipeline UI. It's actually based on a project from Intuit called Argo. And Argo is really meant for CI/CD, but was quickly, it's when you're searching the web for ways to build DAGs, and there's a lot of little hacky JavaScript things, and then there's this project Argo. So it seemed pretty cool, and I think they were already using it for the KubeFlow build process and sort of the end-to-end tests anyway. So they're like, well, wait a minute, why don't we just use this for pipelines? So pretty clever reuse and sort of transfer knowledge from the CI/CD world, which is basically what we're doing here. We're doing continuous integration, continuous delivery of our trained models. So we like the UI. It's simple, but packs in a lot of stuff. Also, some of the other high-level projects here are TF job. This is actually the TF operator. Oh, and then I should mention too, if you go back into your notebooks and look at, if you do the Explore Kubernetes notebook, you'll actually see Argo as one of the pods. So that's pretty cool. TF job, you'll see something called TF operator. That's what's actually sitting there listening for requests to create a TF job, so TF job is, it's kind of a legacy name now, but really it's a way to define a TensorFlow training job in a standard way and have it get picked up by Kubernetes. It's sort of a Kubernetes native way to do TensorFlow training. And the cool thing is that they actually added support for distributed TensorFlow. So we'll actually do one here in a bit where we're going to do a distributed TF job. And then, one of the other projects to highlight with KubeFlow, and as I had shown before, if you go to github.com/KubeFlow, there's 15, 20 projects there now. Fairing is now one of them, which I'm super excited about, because the ability to deploy a notebook as a job was something that Databricks spent 2 years developing. From their notebook, from their product, you can deploy a notebook to a Spark notebook to a cluster, which it seems like this is the easiest thing in the world, but there's actually quite a bit of complexity. And I was sure to get a fairing sample into this workshop today, because this is one of my favorite sub-projects of KubeFlow. And I think once you guys see it in action, you'll probably get pretty excited. So this is the project where you can take a notebook. It can convert that notebook essentially into a Docker image and then deploy that Docker image to the cluster, and you can analyze the results. So this is actually probably the #1 or #2 ask by all of our customers, which is, I have this Jupyter notebook. and it's all fine and dandy, but each time I want to run it on the cluster, I have to copy and paste, and I forget a dependency. This is the project also that'll inspect and see the dependencies that are being used by that, that notebook and then package them up. All right, so let's go back to our Airflow. Here. I have a lot of windows open, so I'm going to start closing things down. Okay, I'm going to go back here. I'm going to hit refresh. So now it's actually doing the training. And for those of you that are curious, you can and want to see more logs, you can either, of course, click here and then do the view log. Some logs being shown here. This is really the sort of Airflow specific logs. There's actually some of the keen of you might be asking, where are the real logs? And there's a bug that's been fixed but not yet pushed to PyPy with TFX and like Airflow, where these logs will start showing up as, or at least the actual training job will show up here, not just the Airflow version of the training. But for those of you that are curious, we can go bounce out here. We can do our get pod. And so there's the Argo UI that I mentioned earlier. That's really the visualization of the pipelines. There's going to be, see, this is the KubeFlow stuff, so don't expect anything to be showing up there just yet. I can either take a look at Airflow. Actually, let's just take a look at Airflow. So instead of doing -f, I'm actually going to just do logs. That way it doesn't lock up the rest of the notebook. And there's some warnings here and stuff. Yeah, don't worry about those. Oh, this is actually the scheduler. This isn't the worker. Where would we see? Okay, yeah, anyway, I'm just going to keep going here. So we can, yeah, the next few notebooks will be KubeFlow stuff. So actually, let's just start it. Let's start the KubeFlow stuff. They can run in parallel. So let's jump to, so 6 and 7, we have to wait until Airflow finishes. 8, let's jump to 8. So I want to highlight here what's going on. So this is actually a very, very simple version, simple KubeFlow pipeline. And this really isn't doing anything except adding 2 numbers and then dividing. And the reason that we even go beyond adding and want to do divide is we want to actually have multiple operations. And so the super simple version that I first had was just one single operation, and I realized I was sort of insultingly simple. So we add in this divide. We're also, so to step back here, the context is we are programmatically creating a pipeline that is then going to get compiled and deployed into KubeFlow, right? And so first thing we have to do is install the KubeFlow pipeline SDK. This is likely already part of this image, but I have it here explicitly just in case this notebook gets run somewhere else. And then we're defining a Python function. So again, we're in Python land. We don't have to do too many crazy things here. We're just creating a function, and then we're using KFP. So we've basically pip installed KFP, which isn't even on PyPy. You have to install it directly from this Google link here. And we're calling func2containerOp. So this is programmatically taking a Python function and registering it with or as a container operation. Now, container should imply or should trigger thoughts of Docker, and that's basically what it is. But it's doing it in a lightweight manner. In fact, the very top here sort of goes into some of these details where by default, KubeFlow wants one Docker image for every step or for each component, which is pretty heavyweight. And so the idea here is we don't want to have to build Docker images and everything. So let's just do something small, or let's stick with just functions, with Python functions. Also, you could have nested functions here as well too. So that was the other idea with like adding in a tiny bit more complexity. So one of our operations is add, and then we're defining this divide function. We're also exporting some metrics that are going to get shown in the KubeFlow dashboard. So this would be the equivalent of showing like accuracy and loss and right. So, and this is just boilerplate code here. This is what we have to write out for this to get rendered. It's called ML pipeline dash metrics. And then, still doing Python stuff. And we call this just to make sure it works. And then we're now going to call that same function that we did above, but we're going to give it a hint and say, you know what, we actually want TensorFlow. Now, the like dirty secret here is that this function actually doesn't use TensorFlow, but we are specifying the base image as TensorFlow. That's a little bit confusing, but you could swap in basically anything here. The point here is that we're able to customize and use a base function that might already be blessed by your organization that has NumPy, Pandas, all the versions of things that you need. And this function then gets packaged up and run within the context of that base image. And then here's where we're actually defining the pipeline. And we're using this DSL decorator. Python version, some Python decorators. So it's adding a sprinkle of probably DSL-ness here to this function. And then this is actually defining the pipeline. So this is like one convention is to call these tasks. So you have an add task that's using the add operation. So pipelines have to be defined in terms of these operations. Operations in terms of these container operations. Container operations are defined in terms of a real-world Python function. Okay. So we have an add task that's just adding these, and it's taking variables here to show we can pass variables, which is always nice. We're then dividing, so we're taking the output of that add and then dividing it by b. And then let's see. Yeah, and then we're then doing something crazy where we're then going to add. And so this is just showing that we can do an add, divide, and then we can actually mix the two. So we're going to add the quotient that's returned by the divide and then add it to C. So kind of a silly example, but yeah, hopefully you can sort of generalize and see how this would fit into your own pipelines. All right, so pipeline func, pipeline file name. So this is a bit opsy here, but the way that we package up these pipelines is through tar files or zip files. So, and all this really contains when it's compiled. So here I'm just defining the file name. So if I put a print here, this is just saying this is the file name to use when we call this compile. So all this comes out of the KubeFlow pipelines SDK. This compile takes in this file name, takes in this pipeline func, which is this DSL tagged pipeline here, and generates. Actually, that's something I think we should do. So let me run through this. It's going to generate the tar file, and let's untar the tar file and see what it's actually generating. Tar XVZF. So pipeline YAML and cats. Okay, so this is the pipeline file, the pipeline YAML file. So of course, everything in Kubernetes and KubeFlow is YAML. And all of this got generated from just a couple simple lines of code. And if you notice, this is my favorite part, all that's really happening besides wiring up input locations and output locations is it's literally grabbing the snippet of code and sticking it in as a Python, as the argument to Python. So this is about as brute force as you can get. But as I'm sure quite a lot of you know, this is literally what people do today. They just do it by hand. So this seems barbaric, but you know, the more and more we can kind of automate this barbaric stuff, the better. Here's the base image. There's some voodoo here with secrets that is a little bit too Kubernetes specific for this talk, but this is where we spent quite a bit of time when we were preparing this workshop to make sure all these things matched up and that your environment was set up. All of those little tweaks have been expressed in the GitHub, public GitHub, so you can grab all of our research and like hackiness over there. Okay, and so I had already run this just now, so I'm not going to run it again, but what's happening here is, here's arguments. We're again using the KFP stuff, so the KubeFlow pipeline, the Python library. We're then calling create experiment. This is a pattern we'll also see in the MLflow. Yeah, also does something like this where we create an experiment, and then here we're just stitching things together just to have a nice run name, and then this is where the rubber meets the road right here. Client run pipeline, give it the experiment ID, give it the name, give it the blah blah blah, give it the arguments, and lo and behold, this pops up. Experiment link here, unlink. Let's see what happened. So, again, we created an experiment so that it's nicely packaged. If you don't create an experiment, it's going to end up in default, and all this gets really hacky. Because experiment is on its own, we can have custom columns here per or for a specific experiment. And while this seems kind of silly that you're like logging this, it's just an example showing how you can take stuff that's happening within your pipeline and expose it to this dashboard. So, again, this is a lot of flexibility, and with flexibility comes kind of lots of different ways of doing things, and it seems very overwhelming and confusing, but it's super flexible, so that's good. We can click in here and we'll see each of the steps. So we could see the inputs, we see the logs, nothing very exciting in the logs. Let's see, and then go to the divide, look at here, got our quotient and our remainder, which we were logging. And then over here, more inputs, outputs. So here C was 17, the quotient was 1. When we added them together, it became 18. Here's our configuration. Here's the input parameters that were tracked for this run. And that's it. So let's go back to, I'm going to stop this. I'm going to be a good citizen and shut these down. I'll shut this one down. And we're going to do something a little bit more complicated. All right. So this example lives here. Here's the code. Here's the actual Py file. You can find that here. What we're going to do is we're going to upload so I've already done this. I've already compiled this, and it's in this .tar.gz here. And if we untart it, we would see pipeline YAML, which is something you could actually do. You can go back to your workshop or workspace here, and under KubeFlow TFX, there's a KubeFlow pipelines and taxi, and you could actually untar this if you get fancy and see what's in it. But for now, what we're going to do is we're going to import this. So, you know, we've seen the previous way that we did it with the simple one was we used the KFP Python library to compile and push this pipeline. Now we're, you know, think of this more like a continuous deployment kind of scenario where we can build the tar.gz with something like Jenkins and then push it into KubeFlow this way. So, but here, let's do it manually. So let's go to, I gotta get back to the workshop here. KubeFlow pipelines, and I think our other, I'm pretty sure Airflow is probably done by now. Let's click upload, import the URL. Let's grab the URL right here. Give it a name, taxi, fiction, tip prediction. Boom. Okay, so this uploaded it. And I can't tell you how happy I was when I finally got this to upload and not show an error. Super exciting. Now, we can create an experiment. XC experiment 1. Run name, so let's just say it's run number 1. We can give it description if we want. All this is a bit of magic voodoo here. So one thing about any pipeline, and this has been pretty much my entire life for like the last few years, is just mapping inputs and outputs and making sure that they end up in the right spot on S3 or on the on like NFS. And now we have Minio, which is kind of a mystery. It's kind of half supported by KubeFlow and not really, but the next version it's supposed to be. So, you know, really it's just making sure all these things are mounted. So let's just know that this works for your environment, but this will be an area that you'll sort of have to customize when you go to apply this to your own domain. And ideally what we ask customers to do if they're on like Amazon, they set up EFS, you know, the Elastic File System, because S3 right now is partially supported, but there's some gotchas later on if you use S3. So today we're just using a pseudo shared file system. It's a single file system, but it is using shared. Oops, what happened here? Okay, run 1. We got the experiments. Here's some other hyperparameters that we're going to test in a bit, but using the actual hyperparameter tuning. And so brute force hyperparameter tuning is us creating 5 or 10 or 20 different runs with different combinations of these values here. But we'll show how to do this a little bit more sophisticated here in a bit. So we started this, and let's make sure it's launching okay. And I see a bunch of questions queuing up here, so I'll address those in a sec. Let's make sure. Okay, so container creating is good. One cool thing about this is it tells you the pod name right here. So click on this thing, you'll see the pod name, and if you want to, we can go back and we can go to our notebooks, Kubernetes cluster, and I should be able to do kubectl logs, give it that exact same pod name, and it's going to tell me what's going on. Oh, it's saying, okay, so here's an example where there's a pod with 2 containers, and this is something if you've used Kubernetes beyond just kind of initial demos, you'll know this exact problem. This is a pod with 2 containers, and when you're asking the pod for logs, you have to tell it which container. And so this is one of those cases where there's kind of this I believe this is called the initialized container that they're calling wait. So any pod that starts up has a natural life cycle where you can specify a Docker container to run before the main thing runs. It's kind of a common pattern, a nice hook to be able to inject something that could do some initialization. So in KubeFlow land, the pipelines, each component, each pod has this thing called wait that waits to make sure that whatever is needed by the main, that has been satisfied by the previous component. There could be nothing in this wait, then it's just a no-op, but in a lot of cases, we'll actually see where it's checking to make sure that the input directory has been created and that there is something in there. And so this was one area that we spent quite a bit of time like debugging, which was we were seeing errors in this. Well, we didn't even really look at the wait thing. We were just looking at main. We didn't really see any errors in main, and then we finally decided to crack open the wait, and that's where we saw all these errors about, cannot connect to S3, your Minio configuration's bad, this component failed before you, so, like various things here. But anyway, back to this. Let's take a look at main. This is where most of the good action is. Here we'll see more beam stuff happening, and then it looks like it found an anomaly in feature payment type. It's giving us some metrics here. So, again, this pod, I know about this pod because KubeFlow told me about it. Where did my KubeFlow go here? That's not the right one. Taxi. So I was in data validation, and that was the pod I was looking at. And here, I could also look at the logs here, actually. So you don't have to go like rooting around inside of Kubernetes stuff. This is also how we were able to debug certain things that were missing. If you have this directory incorrect, you'll start getting errors. Okay. This is one of those tiny areas that we still need to use Google Cloud Storage for, and this pains me to no end that we have some of these dependencies, and I'll explain why here in a sec. Okay, transform. So the transform's happening. You can see these logs as they're happening, inputs, outputs. So yeah, so let me explain this a tiny bit more. The reason we have to use Google Cloud Storage is there's a bug, of course, in KubeFlow, or there's a missing feature in KubeFlow that is being fixed, where so in a sec, I'm going to show you guys some fancy stuff in this artifacts tab. Once this model gets created, there's going to be validation happening. There's going to be the ROC curve, there's going to be confusion matrix. And if you don't write the output to Google Cloud Storage, there's literally a bug in the UI. The REST API doesn't support anything except Google Cloud Storage. So that's obviously changing. That's one of the reasons why they formed the KubeFlow on-prem working group. Again, these are some of the edge cases that we had to suffer through the last month or so to prepare for this. So 0.6 will give you S3 support, will give you file system support for distributed file system. We'll also give you Minio and even HTTP. So you can write somewhere, and then just as long as you can get to that file through an HTTP server, then it'll be accessible to show up in this screen. All right. So here we go. Here's these are the hyperparameters: 1500, 0.1, 3000 steps. Just ignore, pretend this isn't Google Cloud Storage, pretend it's something normal, and click. So this is the trained model. So it's not entirely obvious here, but this is the pod for that training step. Now you're all telling me click on this button, so I'm going to click on it. start TensorBoard. But I want to remind you what the context here is. I'm clicking on a component and I get certain features here specific to that component. So up till now, there hasn't really been anything interesting. If I click on this, I think this is a prediction. So this is a batch prediction. And it's showing if we open this up in larger space here, you could do pop out. Then we see the headers and we can sort, do all kinds of stuff. So this is a batch prediction. This was part of our pipeline. It's just something that we chose to do. Did this start already? Usually this, I think I closed it before it finished, but yeah, open TensorBoard. So this pops open TensorBoard and shows us the metrics. Or should show us the metrics. And this is what it's reading from. Here's our loss curve. You see, I feel like some of this stuff hasn't been generated yet. Okay. So this is where some of this rubber meets the road here. Okay. And analyze model. So we've already seen this. Make this wider, I could pop it out. So, so this is running outside of a Jupyter notebook, but literally if I look at my developer tools, it'll be the same JavaScript that was used there. Don't worry about these errors. Suppress that OCD of all of ours. But it should be the same JavaScript here. That lets us slice and dice through here. So that's kind of cool. Analyze model. Here's the ROC curve. I look at artifacts. Now, some of you might be asking, can you build your own custom viewers? And you certainly can. So, you know, one of the things that like we always keep an eye out when we're sort of like evaluating new frameworks and is how much customization can we do? How much flexibility do we have? And yes, you can build your own viewers here. So confusion matrix, kind of fun. Artifacts, you can pop that out. Some more info there. All super, super duper exciting. Okay. Let's jump back real quick to shut this down and go back to the Airflow ones. So Airflow should have finished. Back to the graph view, and these should all be green. So everything looks good. We even pushed out the model. And so now we can actually analyze. So see number 5 says make sure you unpause. We did that, close that, shut that down. Number 6 is feature analysis. So again, this is using TFX now. We're pointing it. So this is the metadata database. And again, so this is the metadata store. And here, this is actually just using SQLite, just a file. You could point it to your MySQL cluster. So let's run this. And as far as I know, all the notebooks from this point on should be pretty stable. If not, yeah, definitely let us know. So this is installing, doing pip install. Here is where we're cracking open this meta store. So if you remember earlier, I said we were going to kind of crack this thing open and see what's inside. So that's exactly what we're going to do now. So we do store equals get meta store. Then we say store get artifacts of type schema. Shows us a schema. We could actually, there's different types here we can do. In fact, if I do a period, does it work? Yeah, it does. So if I do, my tab completion, I can actually get the model, which I think we do here in a minute. I think in the next notebook, look at validation data, look at the example. So this is all the artifacts that the meta store knows about. Okay, and so let's parse it. Let's do that same thing we were doing before. And it transformed. Now let's see, what else did it do here? Analyze, transform, did a little beam action. So we've seen this in other contexts, but this is, so this should pretty much be the same thing that we were doing before. Okay, so I'm going to go back here. I'm going to close. Open up the Airflow model analysis. So again, we should have run this before, which we did. Here again is our metadata. Now we're asking for artifacts of type model. So if you recall, we have still running this one above here, starting the kernel. Come on. Okay, restart that, reload. Okay, this one's giving us some problems here. Kernel starting, please wait. And be a little bit patient. And the advanced, this one I can close down. Advanced KubeFlow one. See if there's anything going on in my developer tools. Okay, I'm going to go back here and shut this down. Just a minute to recover. Now let's go back. Let's see. Do we have anything more of the KubeFlow stuff? Okay. So KubeFlow, if we go back to the runs, so again, this is within an experiment called Taxi Experiment 1. And now the custom metrics that we decided to export, if we cracked open that that tar.gz and looked at the pipeline.yaml, we would see that we're exporting accuracy and ROC. All right, and then we can compare the two. Once we have a second run, we can click compare. Actually, let's do that. So run, and then do clone run. It's going to be run 2. I'm going to give it some different hyperparameters, hidden layer size, steps 6,000, bam. Let that run and we'll see. So we lowered the learning rate. So we allow gradient descent, more fine-grained steps within there, or movement. And then increase the number of steps, and we'll see. Hopefully we get higher accuracy and better ROC. Let's check back in on our, okay. So Airflow model analysis, so what did this say? Oop, had an extra dot in there. Okay, so we asked for model. So this is actually going to, and this showed us what's inside of this meta store. And we have the ID. So here it's already hard coded because I know that that's the ID. And then we could do model analysis on this model right from here. And then also, this is kind of cool, we could see that for that ID number 11, we could see the lineage, what got us here. executions, artifacts, kind of a bare bones figure, but not too shabby. Taking advantage of matplotlib within the notebook. We can also, instead of limiting ourselves to model, or actually we can just, let's take step number 0, see if there's a 0. Nope, step number 1. Step number 1. So we can kind of slowly go through here and take a look. So a bit bare bones, but it gives you an idea of what can be done there. All right, so let me kill 7. We already did 8 and 9. Let's check on our runs here. Refresh, refresh. Still running. So let's let that run for a bit. I'm going to take a look at the questions because I don't want to get too far without answering questions. Then next we'll do the distributed TensorFlow job and talk about hyperparameter tuning. Then we'll deploy the notebooks. That's the XGBoost notebook. And then we're going to get into the MLflow stuff and some of the bonus TPUs, privacy, and whatnot. Okay, let me scroll up here. Okay, trigger DAG. Okay, thanks, Ansha, good job. So Siren's due, okay, Siren can see them now. Okay, so that's good. What's the difference between ML pipeline and KubeFlow? Okay, I don't quite understand that one. Yeah, I'll be sharing the slides after this. I'll probably I'll post them to SlideShare and send everyone the link. Yeah, and Ansha pointed out pipeline AI/community. I do Atlas for Airflow. I actually don't know. What is the URL structure? Let's talk about that offline. But yeah, I didn't get that work, or I didn't even try to get that working. But yeah, let's definitely talk about that offline stuff. Checks for function outputs as used in function. Yeah, the question here is, in this free-form land of total flexibility and inputs having to match, functions having clearly defined inputs, do we want more Pythonic type of assertions and, basically get notified before the pipeline goes into production if it's going to fail or not, right? So this is, yes, it would be very good practice. I can't think, I guess one way we saw some typing going on in one of the notebooks here, where, see, in the simple KubeFlow, we were, in the advanced one, we were able to show, or to use sort of, Python 3 like type annotations or type assertions, whatever they're called. So this helps out a little bit, but there's still kind of, this is more, will the Python code pass the lint checker, right? But really what we want is to get sort of better notified up front. So there's functions, there's ways to, at the Python level itself, but I think probably what you're getting at with this question is because there's outputs being written to disk and then those are being picked up by the next component, what is a good practice to catch these things early? And I don't have a very good answer for that, except, our experience has been, we just find them in the logs and then go fix them. But yeah, obviously that's not the best way to do it. So that's actually something I'm going to write down and talk to the TFX and the KubeFlow folks about, is ways to catch these things earlier. because I know that the YAML that's generated here, has some typing information. Actually, it doesn't really. The arguments. I thought I saw typing here. But yeah, so like currently right now, you just see in the logs that something's not there, some directory is not there or whatever. So yeah, good question. Good comment that there should be better checks around that. Let's contribute to ensure, yeah, each part of the pipeline accepts and outputs the right data in the right format. Yeah, right now it's a bit too flexible. My hunch, just knowing the KubeFlow community, is this is where tooling obviously would help being built on top. More. So there's this compile phase that we saw here, and in my mind, this should catch some things. I mean, that's kind of the implication of something called compile, right? A step called compile. We could test this a bit and see if it's going to fail if we're trying to pass in things that don't match, like divisor. If I make this. So it looks like this is actually using this. It's sort of cheating by saying, hey, well, we're going to call it right, like directly to see if it passes or not on some sample data. So, think of it kind of like a unit test. Yeah, this has plagued, big data stuff since the beginning of time, since the beginning of Hadoop, with there being lack of tests and ways to catch these things before they clog up cluster resources. So the tar.gz, right, gets uploaded. It's really just a convention that is, I guess, required. So it's more than a convention. You have to upload a compressed bundle, and that bundle could be many files, could have subdirectories, could. So yes, the tar.gz is or .zip. And this is something we've always dealt with, even in the early days of pipeline when we were focused more on the model serving. There's this bundle that you're always uploading. So it makes sense that they would standardize on tar.gz. Okay, 5. How could I unpause the DAG? Okay, so 05. Notebook itself is just instructions on how to go over to Airflow and unpause the DAG. So hopefully, Minzen, you figured that out, where you can go to here, go to Airflow pipelines, will take you here, and then make sure you're in the DAGs and unpause. Sorry if that was a little confusing. You can use KubeFlow on OpenShift, yep. Okay, yeah, looks like. Okay. You can run and compare different experiments in Airflow. That's a good question. Usually, so Airflow was traditionally just designed for launching Spark jobs and capturing the results, but there was always a separate step to analyze. So I think that's a pretty big differentiator between, yeah, here we can look at task duration and kind of Gantt charts of the actual task like execution, but really it's lacking this cool feature of KubeFlow that lets you compare the runs and compare key metrics that you choose to define. So here, run number 2 got a little bit higher accuracy, a little bit higher ROC. So it looks like it probably wasn't worth the extra minute or so that it ran. So I think you hit it on the head here, where Airflow is a means of coordination, but really the overall run analysis would have to happen elsewhere in Airflow land. Okay, these are good questions. I want to make sure I cover them. Okay. Okay, thanks, Gerard. You access all notebooks. Oh, yeah, and then we have Community Edition too. So it looks like some people have to go. Community Edition is always available, community.pipeline.ai. Has the latest, has all this running. Question, let's see, does KubeFlow work with Spark? So I've seen some people trying to get Spark working. I've seen some examples. They were using data proc, which is Google's like EMR basically. It's a Google specific Spark service. So any attempts we tried to get Spark within KubeFlow, we quickly stopped because it was so Google specific that it just made us cry. The short answer is yes, you can do basically anything. As we saw, we deployed a very simple add and divide operation, and then as complex as the same taxi thing that we saw here. So you can certainly run Spark. I'll show you in a bit the fairing stuff when we deploy the XGBoost notebook, where you can kind of generalize it to creating or using the base image as a Spark image and then embedding a Spark call into the like Kubernetes cluster. So the other side of it is Spark just recently, as of Spark 2.3, we're up to 2.4 right now, does support Kubernetes, and so that kind of opens up KubeFlow plus Kubernetes. Okay. He was asking about the Kubernetes pods, I believe. Okay. Airflow and KubeFlow can be used in local. So by local, you mean single laptop, of course. If by local you mean a single node, that's exactly how we're running Airflow and KubeFlow right now. I think you probably mean Airflow and KubeFlow. Can you run it on your laptop? And you can definitely run Airflow locally. That's actually quite easy. Running KubeFlow locally requires that you have a Kubernetes cluster running locally, which isn't the end of the world. Like I said, Docker supports it. So if you just install the latest Docker, which I'll start up here, you'll see, I got some errors there, but you'll see in preferences, you can specify and create a Kubernetes cluster locally. Okay, so the short, and there's tons of instructions on how to run KubeFlow locally. So any way to Airflow to do something similar to this experience with input? Yeah. So the question about Airflow and outputting metrics, I haven't seen it integrated with Airflow. Again, Airflow hasn't really changed in about 5 years, the look and the feel. So you would have to do some sort of external analysis with Jupyter notebooks or something else to pull in that data. You could probably modify Airflow. In fact, I know Airbnb, for example, they forked Airflow internally. They do all kinds of crazy stuff. They do A/B tests with Airflow, and they have this totally custom UI that runs on top of Airflow that shows in real time how different A/B tests are performing, and has a little up arrow and down arrow and shows if it's showing any lift beyond the baseline. Okay, how about SageMaker? Yeah, SageMaker really doesn't fit in here at all. This is, in fact, Ansha and I just went to a talk a couple weeks ago by one of the SageMaker guys at Amazon, and they essentially have their own thing going on. Even for their distributed training, they have their own sort of container like orchestrator. It doesn't really use Kubernetes. It's their internal like Elastic Container Service, ECS. But yeah, SageMaker definitely, obviously you're tied to a single cloud. What you create in SageMaker really can only be used in SageMaker. You have SageMaker libraries that build on top of TensorFlow, and but yes, Amazon actually does a pretty good job keeping up to date and making sure that, in fact, it's my opinion that Amazon actually does TensorFlow better than Google Cloud, right? Yes, and it's because, it's obvious, right? Yes, Amazon has such a huge market share. They have tons of data. They know how people are using TensorFlow. They know what they need. But there was a pretty interesting blog post I saw recently that showed that like really sums it up, where if you want to do what you do in KubeFlow, if you want to do that with Amazon, it's not just SageMaker. You also need their Fargate, which is sort of a pipelining UI kind of, you know, it's a way to like orchestrate different pipelines. Then you need code build to build the Docker images. Then you need, you know, 14 other Amazon services to do what you can do with KubeFlow. Yeah, so keep in mind that each of those 14 services has been hardened and, you know, has tons of support around it, whereas KubeFlow is, you know, much smaller group of people working on it. Okay. Kubernetes can be local, yes. All right. KubeFlow and scale more. We use KubeFlow. How can we scale if we have more hardware resources? So the way that you would scale KubeFlow is, and yeah, so again, this is something we could do at the end of this, where we try to join all of our nodes into one big Kubernetes cluster. But basically, you would do it at the Kubernetes level, and then just have one large Kubernetes cluster, and then you would be deploying pipelines onto that large Kubernetes cluster. And then Kubernetes handles all of the scheduling onto those nodes. Okay. The GitHub repo has everything that's being used here. Yes, we could talk more about that offline. Yeah, and Steph pointed out that the user data CPU, a little more info on setting up the environment. Yep, okay. Okay, all right. Let's move on from some of the tool talks here, CI/CD stuff. Let's get back to yeah, Jenkins. Yeah, so still to this day, I see a lot of like ML pipelines being built with Jenkins. So Jenkins is fine. I think what it comes down to is what was mentioned here earlier, which is what's going to give me the ability to track experiments, compare experiments, and click one little sort button up at the top that sorts my column of accuracy and says, this is the best performing set of hyperparameters. And to do that right now with Jenkins, like this requires a whole ton of plugins, a whole ton of customizations. At the end of the day, that's all we're doing is running one component after another, and pipelining the data, the inputs and the outputs. So really it comes down to tooling. One thing that always bothered me about KubeFlow is it was a little bit too Kubernetes specific, and this is why we didn't jump on it right away. Not like we're going to be using something other than Kubernetes anytime soon, especially us, you know, because we adopted it so early. It's just, I get nervous when anything high level is tied to anything super low level. But then you start to realize that Kubernetes is the new Linux, and now you just kind of forget about Kubernetes and just talk about things that go on top of Kubernetes. Jenkins runs on top of Kube, so you can certainly stitch things together that way. So to scale, you would deploy multiple copies of the same pipeline? No, you would deploy the same pipeline, and it would just be spread across more nodes, right? And so, you know, really these pipelines typically are sequential. There's one component, then there's another component, then there's another component because of the, you know, the further down components are waiting on the earlier ones. But to scale it out, if you wanted to do multiple runs in parallel, yes, yeah, then you would have multiple, right, like basically multiple copies of the same pipeline. All right, so let's move on here. Great questions. There's a Q&A thing here. Unless anything's super pressing, let me skip that and get back to the main line here. Okay. Hyperparameter tuning. So the idea here is we're logically doing a single optimization run. Now, an optimization run could include running many trials. And these are terms that have been coined sort of by the industry, by and there's something called a study, and study info is the information that you've learned from this study. But at like the end of the day, like whether or not you call them trials or jobs or like whatever you want to call them, we're running the same model with many different hyperparameters, right? Like many different, so different learning rates, different steps, different epochs, different, whatever. Typically, these hyperparameters are specific to the type of model that you're doing. So if you're doing, like convolutional neural net, you're going to change the stride of your convolution across the image. You're going to do, various techniques. There's different hyperparameters for the CNN specifically. So trial is a single list of each value of a value for each parameter. So you can get into exponential number of combinations of parameters, the more parameters, right? And so these are hyperparameters, right? So just to kind of get the like terminology straight, when you're training a model, you're learning the model's parameters. How you train the model is called a hyperparameter. So there's parameters for how you're training the model. So which is why they're called hyperparameters. So said differently, I want to tune how I learn the underlying model parameters, and I do that by setting hyperparameters. Okay, and there's different strategies. You're probably most familiar with something called grid search, which is literally if I have 500 different combinations of all of my parameters, and the parameter space that I'm searching, if I want to try learning rate 0.1, 0.01, 0.001, those are 3 different values for one specific variable or one specific hyperparameter called learning rate. If I have multiple parameters, they each have their own space of values. Now you have to specify the space up front. There's techniques to sort of give you starting points and to try out different spaces. Or to narrow the space, there's this algorithm called Hyperband that can actually look at, and as it's running these training runs, it could start to figure out, oh, okay, exploring this side of, or this section of my my hyperparameter space isn't really adding any value. So let's stop exploring that. So really, what we're always trying to do is like reduce the number of trials that we're running, because that directly impacts the time it's going to take to find these hyperparameters. So okay, so we're doing an experiment. This contains many trials to find some objective function that we're trying to either minimize or maximize across all of those trials. So typically we're trying to maximize our accuracy, and in most cases validation accuracy. And then we're trying to do this as quickly as possible. So what they're calling suggestion is actually the algorithm that you would use. And you can experiment with this as much as you want. So here, let's actually go do one of these. Let's pull up 11. I'm going to kill anything that's running. And let's do this. So this is actually, now there's a way to generate this YAML. So actually, before I do this, let me go up here. Let's cat this YAML. Oops. So this defines what they're calling a study job. This is all just different terms for the same thing. I'm trying to maximize my validation accuracy. This is the goal I'm trying to reach. If I reach this goal, we can early terminate. Here's some, so we're defining a range, and so this is learning rate, this is number of layers, which is a hyperparameter, and which optimizer. So this is actually not just changing hyperparameters that we would traditionally think of being numeric. This is actually changing what is the rather optimizer that's being used beneath the covers. So we're saying use random. So there's grid search, which tests all possible combinations, which could get very, very slow, very fast. It's a large amount of space. If you do random, and there's kind of mixed thinking on this. In our experience, actually random isn't really that helpful. We typically end up, there's this side of you. So if you do grid search, that's going to cover all the combinations of all values of all hyperparameters. Very, very expensive operation. If you do random, the idea is that it's pretty much almost always going to be, it's definitely faster than doing grid search because you're not doing all of the space. You're sort of randomly selecting and then taking the best of the randomly selected. There's always in the back of your head the fear that you didn't try a particular combination that actually is the best. So while random is faster and you can sort of statistically say that you will always end up, getting approximately the best, there's still this thing in the back of your head that says, we have enough compute. We could do this in parallel. Let's just run all the combinations. Okay. Here, this is actually an MXNet example, and it's training MNIST. And you'll see the term Khatib. This is the hyperparameter tuning. This is a sub-project within KubeFlow that's been built for hyperparameter tuning, and contains all of these, goofy terms like study job, and has like a pretty slick UI here that we'll show in a sec. So let's run this. Study job created. And let's go check the parameter optimizations tab. So I'm going to go back here, parameter optimizations. I see this is running. Study ID here. I'm going to click into it, see what we got. So this is the study config, right? Yes, config. So this is defining the feasible space. So the hyperparameter tuner will check all the values within here. These are integers, so it's pretty easy. 2, 3, 4, 5. This one's a little bit tougher. There's quite a lot in between. And categorical for the optimizer, it's going to try atom, stochastic gradient descent, or FTRL. Study results. So now we can start to see, and I don't think this is completely done, but yeah, because we don't have accuracies just yet. But we can click in and look at the workers, start to take a look. So these things are pumping out metrics throughout their runs. And then, see, these are the different hyperparameters. So learning rates, try and use different optimizers. Oh, and I think we only requested 3. So it shows, and because this is random search, it's just choosing 3 points randomly, and then should tell us here in a bit. And so this is still running. We could go back to our Explore Kubernetes, run this get pod again. And we see study job right here, but the actual study jobs are these, I believe. Yeah, 101 seconds. So these should match what we see here. So let's see, where's the, so 094, so we see this one matches that. OEC matches this. And for those of you that want to go poke around at logs, you can take a look at those here. I don't know if the UI actually shows the logs. Let's see, which one here? Okay, so we have validation accuracy. This is the dream come true. I could just click on select. I see my validation accuracy 0.93. This looks like the best combination by far. And we know that of the 3 samples that I chose, the atom optimizer is giving us the best. Number of layers is 2, and learning rate is 0.273. What would be nice is to be able to kind of combine these things and see them all in the same UI, and I know that that's being worked on. Right now, these are independent projects that have been sort of cobbled together by the KubeFlow community, and you know, it's kind of V0.5 stuff. All right. Okay, move this over. So let me look at a couple questions here. Let's take a quick break too, since we haven't had a break in a while. It's 2:15, let's come back at 2:30. And 2:30 p.m. PT. And I'm going to go through the questions here and try to find, let's see, scale, cache room. Yeah, early stopping. Okay, so let's come back at 2:30, play around with the hyperparameter tuning, maybe change it to, you could change the number of, so you can edit this file. You can go into here, and it's going to be under hyperparameter tuning. And if you want to, you can edit it and do the request counts. Maybe make it 30. We can call this grid search. And I don't know if request count matters. Search algorithm. Oh, yeah, here it is. It's the request number. Let's do. You could change this to grid. And to save that back here. So this is actually grid search now. Let's see if it works. Okay. Let's see, parameter optimizations. Okay, here's our grid search, doing grid search, click in, make sure it got study results. Okay, so it might only, oh no, it should be doing, okay. I think there's a different configuration for grid search that we're not passing everything, but okay. Let's connect in about 15 minutes. Okay, we're back. Some good questions there. Tried to answer as many as I could. Someone asked a good question just now, training accuracy versus validation accuracy. Real quick explanation on that. The one you want to pay very close attention to is that validation accuracy. Someone responded, I think Jason responded with the difference is that one of them is on your training data and one of them is on the holdout data. And to give a bit more context there, when we train the model, we're purposely holding up, 10%, 15, 20% of the data that we've been given to train. And we do that on purpose. And if you haven't done much hyperparameter tuning, this won't really make any sense. But you need to hold data out. So there's actually 3 sets of data that you're holding out. Usually it's like 80, 10, 10. So 80% you train the model. 10% you test your hyperparameters. And that's how you find the best hyperparameters. Once you found the hyperparameters and train your model, then you have a test holdout, or yeah, I always confuse them. But the final 10% that has not been seen during hyperparameter tuning, during training, is used to validate or to like ultimately test your model and the final hyperparameters. That's why you actually need multiple steps of validation. So training validation is just one, that's only done on 80%. But now you want to, and so each time you don't want the model to have seen that portion of the data. Otherwise, you're leaking information, which can then be, which then blows the experiments. And let's see, someone asked for the source code of one of the examples. I'm trying to find it. I didn't find it on a quick scan here, but I can definitely find it because yeah, that's where the preview starts to make a little bit more sense. Okay, yeah, so follow training set, cross-validation set, which is shortened to validation set, and then the test set, which is the final validation on the best model and best hyperparameter set that you found earlier through the tuning. Okay. All right, let me unpause here. All right, so this is one of the more exciting. So this is the final section, but we do have kind of the bonus section, which we can go through pretty quickly. So I think this section will probably finish up, I think, in the next half hour, 45 minutes, depending on how much discussion. And again, I'm going to leave the servers up till 4:30 so that you guys have time to explore on your own. Beyond that, you can either use the scripts that are in the KubeFlow TFX workshop and GitHub, or you could actually just use Community Edition, which has running versions of all of them. Okay, so deploying a notebook as a job, like I said at the very beginning, this is one of my most asked for features. How do we take code, wrap it into a Docker image, deploy that Docker image as a job onto the Kubernetes cluster? So I really like that logo with the Docker and all those things. So deploy notebook as job, blah, blah, blah. All right, deploy XGBoost. So let's get back to our notebooks. Shut down anything that you got going. Shut down the tuning. Oh, there's 2 hyperparameter. What's that all about? Got a duplicate notebook there. Okay. So deploy XGBoost. So here's code. So we're doing our normal imports, except we're adding one more import, which is fairing. Fairing is the name of the sub-project. So if you go to the KubeFlow GitHub and then go to one of the projects here, it's called fairing. Bam. And one of my least favorite things about the KubeFlow documentation is the README contains almost nothing. And you click around, you end up getting to the same stuff here. This points you back to the repo and back and forth. So the short of it here, though, I've summarized the good stuff for you. So fairing, kind of ignore this. This is one of those sore points where it's a tiny bit G-Cloud specific. And really, it's not that G-Cloud specific. It's just that running within Google, it's a lot easier to use their registry than to have to set up Docker credentials for Docker Hub. It was just going to leak too many secrets and stuff, and I didn't feel like doing that. So, to me, a Docker registry is a Docker registry. It doesn't matter where it is. But this, just ignore this. This temp directory, for some reason, has to be here the way fairing works currently. These notebook servers, when you spin them up, don't have a /tmp, and apparently this is required by fairing. So I just said, screw it. I'm just going to create it here. So, again, just small little bugs here. So let's install this. It's installing scikit-learn, pandas, XGBoost, fairing, all pretty normal stuff except for the fairing, which is new. Okay, fairing looks like has dependencies on G-Cloud and all kinds of other crap, Google Cloud specific stuff. And this is because it's automatically able to push the Docker images to G-Cloud. It's kind of interesting that you don't see any Amazon stuff being pulled in here. So again, this is one of those areas that really irks me where there's subtle dependencies. Now, this doesn't really cause any problems, except for sometimes these Google Cloud libraries import different versions of, JSON libraries or YAML libraries or whatever, which then could cause some dependency, hell later on. Okay, but besides that, let's just pretend like there's absolutely no Google dependencies here. We're just slurping in a data set, train CSV. And you'll notice we've got some hyperparameters here for XGBoost, pretty standard stuff here, early stopping rounds, test fraction, learning rate, okay? Doing some, this is what we're actually calling training model. Turn those down here. This is where it's downloading. Now, this is all pretty standard stuff. You can kind of scan this and say, okay, I see the Panda stuff, I see where we're doing a little bit of feature engineering here, checking, dropping any, So there's the computer. Okay, so let's define that. Now, we haven't really done anything except define these variables and define some constants. Now, sorry about that. I was speaking the whole time on speakerphone, I guess. I had my headphones in, but my headphones weren't plugged into the phone. All right. So we've defined this set of functions here, and we're now going to call this magical fairing configure, and then we're going to run and evaluate this. So see all this? This is actually building a Docker image. This has already been built, actually, so it's running a little bit quicker, and then it's layering on. It's pushing the image. This is just pushing it to Google Cloud by default, and then it's now trying to start this up. So waiting for this to start, if you go to your Kubernetes cluster and do get pod, we should see fairing job right here. Container creating, that means it's pulling the container down. So we've created the Docker image, we've pushed the Docker image to a Docker registry, and now we're starting a job that's referencing that Docker image, and so now it has to repull it. It's basically kind of the flow there. So all of that was done with just one command. The rest of this we were able to stay in Python land, land that we're familiar with and happy with. Once this, once Kubernetes learns about this Docker image and can start up that pod, it's going to then train the model per, oh, and also keep in mind that this command slurped in any dependencies that were required. So that's kind of nice. And then here we go. So we see the validation, root mean squared error, and it's going to run for whatever it is. It was able to, looks like maybe stop early, best iteration, and mean absolute error, tells you how many rounds. So that's pretty slick. So that's XGBoost, one notebook, and one small call out to this fairing project. Very, very sophisticated stuff, super exciting. All right. So let's close this. I'll actually close everything here. Jump back here, see what else we got. Okay, so that's it for the regular content. I wanted to jump in and get you guys kind of end on a fun, happy note here, which is let's do some TPUs. Let's take a look at MLflow, which I'm going to call yet another experiment tracking tool. Yet another, I don't know, that doesn't have a good acronym, but MLflow will give you yet one more place to store results of an experiment. And so this is actually one of the reasons why Databricks created this project is they saw the Frankenstein thing happening. They actually hired one of the early project managers for TFX and kind of the start of KubeFlow. So, you know, I'm sure Databricks from this point on will be building on top of MLflow and trying to unify. You know, there's a fair amount of fragmentation. We see here KubeFlow is only on 0.5. It's taken them a year and a half to get to 0.5. It could take another year and a half to get to 1.0. Things are moving, you know, nicely, but we still see fragmentation with all these UIs. So, you know, good opportunity for someone like Databricks to take this over. If they integrate it with Spark, yeah, that'll be game over there. So we've got Redis. I want to show Redis plus TensorFlow. The PyTorch stuff wasn't quite working when I last tested it yesterday. We'll talk a little bit about TensorFlow 2.0, and then I do want to highlight the privacy libraries. So let's get right into it. Oops, I'm not quite done yet. So let's do TPUs. So here's Keras, and I'm going to trust this thing because that always bugs me every time I see it. And I'm going to run this. So we're on TensorFlow 1.3.1 or 1.13.1, sorry. The examples tend to work better because of this contrib. And we're able to get to the GPU or to the TPU. So this is very exciting. Keep in mind that TPUs are remote devices. So they're not their own clusters. They're on super high-speed connects into the CPUs that are accessing them. And by CPU, I mean the Google Cloud instances that we're currently on. But unlike GPUs, which are typically on the same in the same rack or on the same board, you know, these are actually in separate racks and connected. This actually bothers some people. Some people like the GPU being local and that they don't have to think about it. I was talking to a friend recently who says he just can't stand to put this kind of code into his TensorFlow code where he's referencing this remote URL. It just bothers him to no end. And so instead of doing this, he spends his time installing you know, GPU CUDA toolkits and upgrading and falling behind there. So that's one area where he and I don't agree because I do like these TPUs, how they are like remote accessible. Okay, so here we're going to download some data and do a little MNIST action. And we'll see actually how fast these things are. So let's see here, not yet. So TPU cores, workers 1. One thing I haven't tested too much is multiple people accessing the same TPU endpoint at the same time. So maybe this is like all of us trying to hit these all at once. Okay, so TPUs are fast. That's the big takeaway from that. See if that finishes at some point. Next thing, if I recall, was MLflow. So we have the classic wine quality. Very cool. We see a bunch of features here, and let's see, this is the notebook. Pretty common example here. So the key points to note here are we're obviously importing MLflow, and we're pip installing it here. This is the most recent before the 1.0. It's pretty similar, but I did want to update too close to the workshop. And yeah, here's some helper methods to evaluate. This should all be kind of familiar boilerplate. And we've got, so now we have this well-known directory called Mount Pipeline Users. This is a shared file system. And we're creating this experiments directory. This is kind of, boilerplate Python coders building up strings here. We have an experiment called wine. So setting the experiment name, this is how you do it in MLflow land. We saw how to do it in KubeFlow land. We're going to read in the data set. We're going to split the data. This is, so, again, this is only 2 different data sets. Or sorry, we're splitting, it's the same data set, but we're splitting it into 2 instead of 3 like we have been discussing. The idea here is that we're not actually doing hyperparameter tuning. All we're doing is making the assumption that we've chosen correctly. And we're using, these are the hyperparameters into this particular, this is the ElasticNet model. And these are the only ones that we're going to do. So we don't need any other data set to compare. All we need is one data set to train, and then we're going to assume that's the golden master, and then we're going to validate it with the holdout set. Okay, boom. Oops, I didn't do the pip install. Run this again. Everything is just poking along here. Okay, so we got some data. Wine experiment did not exist, so it created a new one. That's an okay. That's an info. The elastic model with these hyperparameters gave us this. Now, I've done with MLflow, I've done brute force hyperparameter tuning, and I can't off the top of my head remember if MLflow supports hyperparameter tuning. I believe it does, actually. I think you can, when you define your, like there's an MLflow project file that you can create, and you specify different versions. So within MLflow, there's a concept of parameters, which are your hyperparameters, and then metrics, which are the evaluation metrics. And these get logged. Pretty much every major library within MLflow, or within like machine learning, is supported by MLflow, basically meaning scikit-learn, TensorFlow, Keras. So there's sub-projects here, and you can log your model, and when you say it's an sklearn model, this will log it as a pickle file and do some, some other fancy stuff. So that's pretty cool, but let me show you the coolest thing. So the next step is check the MLflow tab. Let's go back here, MLflow. We see the wine experiment, and here we have yet another way to compare runs. So actually, let's do this. Let's go back and do this again. Except this time, I'm going to do 0.2, 0.2. And let's run 0.2 and 0.2. That should have logged it. We didn't get an error message or an info message, so I think it found the experiment. Let's hit refresh here. 2 runs. Now we can compare these runs. And we can see kind of, there's only 2 different points here, so it's not that interesting, but we can get some pretty rudimentary ways to compare. So what we're seeing is multiple ways. Now, you can generate this. You could actually embed this into your Jupyter notebooks to present them to whoever you plan to present these to. There's one more plot that I thought was pretty cool. I think but yeah, so this is, pretty bare bones also, but it's a pretty straightforward, like, open source project that's, kind of fun to keep an eye on. Okay, next I want to say is maybe Redis. So Redis, as I mentioned at the beginning of the call, is a way to store data in a distributed cache. So you have a bunch of servers sitting out here. You don't want to go to the database every time, so you are going to cache certain data. This is often used, if you think the classic gaming company that uses, that's keeping leaderboards in memory, and or Facebook uses memcache pretty heavily to co-locate friends that are commonly talking with each other, to keep them on the same server so they end up in the same like memcache cluster that is co-located. So caching is very important, obviously, in computer science and most workloads that we see. So this is a way, so this is Redis's way of saying, hey, we don't do anything with machine learning. We're getting requests where people want to actually make predictions. So this Redis AI stuff came out shortly after Redis Streams. So Redis Streams is yet another streaming technology that lets you, Redis is built on C and very, very fast. And conveniently, TensorFlow is written in C. And PyTorch has a C library as well. So Redis also came out with something called Redis modules that lets you embed things into the Redis runtime, something they had never done prior to, I believe, version 3. So you can now take your own C libraries, like lib-tensorflow.so, for example, and embed it into Redis, and it will run right alongside this data that's flowing through Redis. So if you follow this example, what we're doing here is, we're installing Redis. Redis AI just got an upgrade last week. And scikit-image, just kind of a scikit-learn image library, kind of useful. And so Redis gives you these core constructs called tensor and blob tensor. And blob tensor is kind of what you probably think it is, which is a blob like an image or video or like an audio clip. And let's see, we're going to connect to our Redis master. If you go back and look at our Redis or our let's see, Kubernetes cluster here, you'll see we have a Redis node running right there, Redis master. The name, the internal DNS name, internal meaning within Kubernetes, is just Redis master. And so I'm just calling this Redis master. So I don't need all the gobbledygook at the end. I just need Redis master. I give it the port to connect to. Because Jupyter is running inside of this Kubernetes cluster, and because Redis is running inside the same Kubernetes cluster, these could be running on multiple nodes anywhere. And as long as it's the same Kubernetes cluster, it can get to all the other services. And it can get to it by its native port. So there's no way to, or there's no reason to open up, certain points of like ingress. So this is all internal. So we're saying the Redis AI client, we're creating a NumPy array, pretty familiar stuff for a lot of us. And it's just 1.0, 2.0. So this is very simple. And then we're taking that, we're creating a Redis tensor. We're calling tensor set. This is a very simple API by Redis, giving it this vector. Says, okay, thanks. Okay, thanks, Redis. We're asking it to, so tensor gets. So Redis operates in this kind of caveman-like speak where it's get and set, and that's pretty much it. So tensor get, it's just returning, saying what the shape is. Okay, that's exactly what we put in. That's what we hoped. Let's get the value. Should be 10123. And now let's treat it like a blob. Okay, let's get the blob. It's still able to handle it. And then, okay, so what are we doing here? So let's. What we're going to do now is we're going to make predictions. We're going to load in the ImageNet, the inception model, which has been trained on this data set that's called ImageNet. Before we do that, we're going to load in the classes. So there's 1,000 classes in this JSON. If I cat ImageNet classes.json. This is all of the classes that this data set has been loaded with. So here we have flowers and goldfinch and stingrays, hens, all that kind of stuff. So we are loading that into this thing which we're going to come back to and use later. But for now, let's look at what's, oh yeah, we're actually using ResNet for this. That's what it is. This is the ResNet model that's been trained on ImageNet. So let's download it. Boom. We're going to load it in, and then we're going to call set, model set. We're going to give it the name of the model that we're going to refer to later when we make the prediction. Say it's a TensorFlow model. Say use CPU. So like Redis supports GPUs. And in that case, it would load the TensorFlow GPU version. We're going to say inputs are called images, outputs are called output. This is important because this is how we're going to set values and get values out of Redis after we make this prediction. Okay. Also, we can load in an arbitrary Python script, which we're going to use for pre-processing before we make the prediction. And after we make the prediction, we're going to post-process the output. And so the context here is we're making a prediction by passing data into Redis, calling the model on that data, and then getting that prediction back. And in doing that, there's certain things we have to so for example, we have to crop the image or do something to the image. Well, that can be captured in this arbitrary Python script that we're loading into Redis. Similarly, the output, maybe we want to convert it from the numeric prediction into a string. So instead of returning 48, we want to return it's a Komodo dragon. That's why we have to load it into this, because we're going to then use it to reference later to return the human readable. So here we're going to load that. We're going to pass in a cat. We're going to create a blob tensor. We're going to show the cat. Very exciting. We're going to get the tensor to make sure everything's in there. It's 224 by 224 by 3 colors, red, green, blue. There's just kind of a slice of what the data looks like. These are color values between 0 to 55. Okay, okay, so here is where we're going to set the input. We're going to pre-process the input. Oh, and that script above has methods called pre-process and post-process. So the script above, if you go and actually cat this, we should see methods. Right there. So all it's doing is just doing simple conversions, some simple transformations, and then calling post-process, and then showing us the prediction. So we're passing that cat in. and it came back. So that one took a little bit of time because I had to load TensorFlow. So it went from 2 seconds down to 0.177 after it loaded. Here we're converting it back, and it says this is a tabby cat, which someone told me this isn't a tabby cat. So maybe it's not a very good model. But guitar is pretty cut and dry. Acoustic guitar. This is the creator of Redis. I did this as a joke. He was watching my talk at the Redis conference. And I ran him through his own technology here, and it predicted barbershop for this guy. So pretty funny. Always makes me laugh. All right. The next thing I believe is, you know what? We didn't do a TensorFlow serving example, so let's do one of these. And this is fashion MNIST. So here we're actually going to, so this is kind of like the reference MNIST, except instead of numbers, it's fashion. We're going to try to detect if it's a shoe or a purse. Doing a little pre-processing. I'm not going to bore you with this code. Create a Keras-based CNN. The context here is we're going to deploy a Keras model, start up TensorFlow serving, and then hit it with a REST API. So very straightforward. We're going to do it all within the browser, within Jupyter Notebook. So here it's training. Let me see if the TPU one finished yet. I don't know if the TPU one finished. Okay, saving the model, saved it into this temp directory. This is a very useful command. I have found myself using save model CLI. There's actually a Python version of it as well too, where you can inspect, if someone just gives you a model out of the blue, or you want to validate that the model has the same inputs and outputs that you're expecting, you can run the save model CLI to quickly inspect it. And this, 9 times out of 10, this helps me solve like whatever problem I'm having with serving, where they're expecting 228 by 228, and we thought it was 299 by 299, something like that. Oh, that shouldn't be there. This actually does work. Okay, boom. All right, so let's install TensorFlow serving. This is going to actually run directly in here, and then we'll make a Python request call. So server log. So this is the example that we're passing in that we want to make a prediction on. And it was actually an ankle boot. Okay, so ankle boot. Let's see. Thought this was a pullover and actually is a pullover. Trouser and actually is a trouser. So pretty cool. So we're making the request call right here, just like we would from a browser, except it's doing a post here and calling into the model. So by default, it's goes v1 models, then the name of the model, and then the type of prediction that we're making. All right. So that was a serving example. Let's do a TensorFlow 2.0. So this is one of the biggest changes with TensorFlow 2.0 is eager execution. This is the ability, so the TensorFlow code that we've been seeing for the last 3 years is very barbaric. It's very much like Spark, where you are building up your DAG, your graph of execution, but not actually doing anything. And when you were first learning Spark, you were probably like, is this running? I don't know if it's running. What's going on here? It's not giving me any output. And for some reason, Spark became popular, even with this absolutely barbaric and non-intuitive way to execute. So the data science community is not as tolerant, and they've been complaining about this since day one, where TensorFlow, it's okay for data engineers, because apparently, they are fine with building up these goofy computer science-y execution graphs. But data scientists, this is my personal opinion, aren't as tolerant, and they want something more natural, more similar to MATLAB and tools that we used in school and after school. So you can now switch, and by default, this has been turned on in TensorFlow 2.0. But here we're going to actively put TensorFlow 1.0 into like eager execution mode. And from this point on, everything I run actually happens just as we see it. That's pretty slick. Before, this would do nothing until you called session.run, and then session.run did a whole bunch of magic, and then you realized that you didn't actually do what you were trying to do. So in the world of ad hoc sort of analytics and ad hoc data science, we want to get results right away and make sure what we're doing actually makes sense and visualize things in the notebook and not have to wade through a whole bunch of code. So this is really slick. And this is one of the biggest changes. Monday, in 2 days, there's a meetup planned with one of the committers or contributors to Swift and TensorFlow. And he's going to talk a little bit more about the auto differentiation behind TensorFlow, why Swift is a better language than Python for TensorFlow. That part's a little, I'm a bit skeptical of that part, but should be a good discussion because I have a lot of questions for him. So yeah, eager execution is a big one there. Keras also, the fact that Keras is now finally the de facto standard for TensorFlow is very good news. And I think we have one more. Yeah, this privacy notebook. So let me give you kind of the gist here, and this is something you guys can go take a peek on your own after this, but there's this concept called differential privacy. And Apple actually made a big deal out of this about a year ago, I think, at their WWDC conference, where they said that they've been using this technique for a while. It's built into the iPhone. Yeah, everybody should be using this. And so TensorFlow actually now has this library. It's a first-class citizen. Let me make sure it's still there before I say it. Yeah, first-class citizen. And what we're seeing here is more and more of these algorithms that are core. Like, looks like someone just updated logistic regression with new privacy analysis. So more and more models are being made privacy aware. And this is very important. So as I said earlier this morning, it's one thing to try to anonymize your data, but sometimes that's not good enough. Because, like, imagine you can do all the anonymization in the world, but when you go and put your model online, people can start to learn the model, right? And could potentially back in. Or you could take one data set that's been made anonymous and combine it with another data set that's been made anonymous, but together you can actually figure out and uniquely identify. And this, the most common, most widely talked about was the Netflix data set that was launched as a $1 million prize back in 2006. Shortly after the prize was awarded, a bunch of lawyers came out and said, hey, you can combine the Netflix data set with IMDb and uniquely identify with a fair amount of confidence who actually wrote the review and gave this particular rating for this movie. So this caused a whole big stir. Netflix ended up paying, I think, close to 9 or 10 million in retribution for this. It was all based on the amount of the prize. You know, once the prize was awarded, that's when the lawyers pounced because there was a dollar value assigned to this. So here's the deal. If you have differential privacy, what you're doing is during training, you're basically flipping a coin is like kind of sort of high-level way to explain it, where you're introducing randomness into the training process. But because you're controlling the randomness, you can subtract out that like randomness when you need to, which is during prediction time. So there's a whole bunch of more like complex stuff behind this, and there's some, I've actually learned quite a bit from some podcasts. If you're in your little podcast app, search differential privacy. There's really only about 10 or 20 actual talks on this kind of stuff, but this is gaining more and more popularity. Now, what happens is you have to, so there's this balance you have to make between accuracy, privacy, and latency. And these all tend to affect each other. This is like the CAP theorem of distributed systems. You have to make a trade-off. You can't have a 100% accurate, 100% private, and 0 millisecond latency model. It just will never exist. The second that you start to move the needle on accuracy, latency, or privacy, it will start to affect everything else. So you have what's called a privacy budget. And if you ask any company and say, how much privacy are you willing to give up, they're going to say 0. And you're going to say, well, I can't help you because that doesn't exist. So what you start to do is build in a small amount of privacy that you're willing to give up to maintain accuracy and to maintain very good speed for your predictions. So there's a couple magic hyperparameters here, like delta, and let's see, batch size, obviously. So think of this as training. I mean, all this is doing is training, but it's introducing this extra noise within this privacy budget that you've allowed. Okay, so let's do this here. Let's just run it. It's telling you, boom, boom, over 19 steps, satisfies differential privacy. Oh yeah, so there's epsilon and then delta. So you can read about those on your own there. And here, so all we're doing is we're still using Keras, still using everything that we're familiar with. We're just using a different optimizer. We're actually wrapping the typical gradient descent optimizer in this differential privacy optimizer, which is familiar with your privacy budget. It's done some pre-calculations up here to figure out what is the correct or the best epsilon and best delta to use for this budget. And then it's going to introduce that randomness in here. But at the end of the day, you'll see we still have a saved model that we've exported. We get some other metrics here, epsilon 2.45. And now we have a differentially private model that can be deployed. And it will be very difficult if you pass in the, if you're trying to reverse engineer this model, this becomes much, much more difficult. Okay, so pretty cool stuff there. It's a very active part of the TensorFlow scene. And I think that's it. So it's 3:15. Let me check Q&A. It's a comment to recommend, pattern due to data prep in Spark, Spark TFX. Yes, we see a majority of Spark jobs either, actually we see, I'd say 70%, yeah, maybe 60% of our customers use Airflow with Spark. So that's a very, very common thing to do. If you think of Spark like a less opsy Jenkins, it's really, you know, and also a little bit or quite a bit more data science friendly in that it's based on Python. So when you're in Jenkins land, you're writing Groovy scripts and doing all kinds of hacks, and you're kind of you know, dealing with all these plugins from all over the place. With like Airflow, it's just a nicer way to script and run your Airflow, your like Python. Let me see here. Check the chats. It gets pretty dense. Okay, differential privacy, great. You're right. Yep. Oh, I think we did miss the distributed training, didn't we? Okay, let me just back up here real quick. ML. Okay, take on. Okay, one sec here. Okay, one would normally train the models in Jupyter. Yeah, so people do turn their IPYNB notebooks into a Py file and run as a batch file. That's common. You'll see fairing basically takes that step away. So you don't even need to do that. You would just, within your Python notebook, just like we did in the fairing notebook, we would run the fairing Python that command that'll wrap up that function and pass it and create a Docker image out of it and basically create the batch version of it. Let's see, question about Docker now in the system. That's a warning, ignore all warnings. Yes, ignore the warning, okay. Mike keeps, yeah, sorry about the voice quality there for a little bit. Hopefully that didn't go on for too long. About 10 minutes it looks like, okay. If we're using a different kube cluster as a different Docker repo, where do we make the update? Yeah, in fairing, there's a way to configure the Docker registry. I forget where it is, but if you look at in the fairing docs, it's like fairing set config, and you give it registry equals, and then give it the those like Docker registry coordinates. Let's see, if we're using a different, okay, okay, I have a clear secret. Yeah, see, and Paul, as Paul points out to Teresa here, you could use any registry that you want. At that point, it's that last comment by Paul, you will have to configure a Kubernetes secret to pull the image that I was avoiding by just using gcloud and Google's thing, because we're running, these instances are running inside Google, I put a permission on all of our instances as they spawn up so that they're completely like transparent. And that, yeah, that's on purpose. That's so that, you know, people don't get a hold of the secrets. But as Paul says, you would have to configure the Kubernetes secret yourself to pull the image, and I was just skipping that. Okay, warning, yep, skip that. TPU address. Oh, we have an unhealthy, interesting. I actually didn't see the unhealthy TensorFlow. That's, that's hilarious. We probably had about 30 people, well, no, we had about 90 people hitting it at the same time. Oh, okay, and I'm running it again. Okay, so running the TPU again worked. And let's get the TPU versus FPGA. Yeah, FPGA is pretty nice. I haven't actually worked with them. I know Amazon supports them. I know, you know, and obviously TPU is only specific to Google, so that's a big limitation. I do know people getting pretty good performance out of their FPGAs running on Amazon, but I have not done a side-by-side comparison. Okay. When would you choose MLflow versus KubeFlow? Yeah. You know, this is a tough one. This is something I've been kicking around actually the last few weeks as we start up a new project, which is I'm very reluctant to go with the current version of KubeFlow. I like the UI, I like the concepts, I love fairing. Fortunately, fairing you can use outside of KubeFlow, so that's nice. Fairing just happens to fall under the KubeFlow project, I guess, for convenience. At the end of the day, we need a way to track experiments, and being familiar with the Databricks engineers that are working on MLflow, I'm very comfortable. The people that they chose to work on it were some of my favorite folks there. Very, very thorough, very productive people. So I like MLflow. It's also simpler than KubeFlow. I mean, KubeFlow is massive, and it's the result of them trying to do quite a lot with not a lot. I believe now Google has some engineers dedicated to KubeFlow internally, whereas a year ago they were dotted lined from other teams. So that's good to see. That means some of the UIs will or some of these concepts will come together. KubeFlow is a humongous superset of what MLflow offers. If you just want to compare runs of experiments and you want to do your own hyperparameter tuning or use MLflow stuff, yeah, I would just stick with that, honestly. MLflow supports PyTorch, yeah, absolutely. In fact, I think there's even MLflow PyTorch examples that are first-class citizens. The KubeFlow supports Docker and Cloud. Is it that only KubeFlow supports Docker? So yeah, KubeFlow really prefers that you do everything with Docker. Cloud-like environments right now, that's the case, but that's going to change very soon with the working group. It's 11 p.m. Okay, thanks a lot, Steph, for sticking around. Yeah, I got a timeout too in TPU. I was trying to run TPU. I think we were all just hitting it at the same time. So is there any way to deploy MLflow model on Kubernetes for serving in real time via unified for different types of models? Deploy MLflow model on Kubernetes for serving in real time. I don't quite understand the question, but MLflow right now that we're using runs in Kubernetes for serving in real time via some unified interface. Oh, so serving in real time. Okay, I'm getting confused, Pramod, by the serving in real time. I'm thinking that's model serving, which MLflow doesn't really support. Unified interface for different. So MLflow will support any model that can call log_param and log_metric. So in fact, there's an example. So Keras has a first-class API called the callback API. And you can have any callback target. You could have Slack as a callback target. You can, and so you can, so there's something called the MLflow logger that works with the Keras callback system, where after every iteration of training, every batch or every epoch, you would write to MLflow. So it's super flexible in that it's basically just a REST API that can track data. We cover distributed. So we didn't do the distributed training. So let me do that one real quick. Don't know how we missed that. Oh, that actually might have been one of the notebooks. Oh, number 10. Okay. Yeah, and distributed training, it's literally, it's the same, it's similar to the hyperparameter thing. We're going to get, so just run, so yeah, this notebook launches, and then we're going to go look at TF job over here. You see distributed training, we see it's pending. So this is spun up 3 workers and it's crunching through, and then you can go click and see the results. Okay, let me go look. Here's a good primer on differential privacy. Awesome. HBase can help data ingest instead of Redis. Sure, HBase is good. Like HBase. Airflows, you can specify bash commands. It's compiled the Airflow. Oh yeah, so that uses the bash operator. You want all your CLI commands, spawn, spread clusters. Yeah. So Jason, you have a good argument here for Airflow and bash operator. I always end up using that, even though I have other operators I could use. So I like this. There's also a Kubernetes operator actually that'll can run, Kubernetes type commands. One question for you, Jason, is how about Airflow versus Jenkins? I could do all my bash operators in Jenkins without even creating any Python code. I just put them into my Jenkins pipeline, right? So just kind of a thought experiment there. Could you show them materials we can go over? Yeah, so I'm going to send out a link with the video and the slides. AWS compatibility of KubeFlow. Is it easy to migrate from Google Cloud to AWS? There is an AWS either a working group or some support for AWS with KubeFlow. It's really what you want to get to is Kubernetes compatibility and not any type of cloud specific. That's really anyway we're targeting, because we are multi-cloud with a lot of our customers. We need as simple as possible the same bits to run across all environments. So getting KubeFlow to run on AWS, I mean, you can run this particular workshop on AWS, except for those 2 or 3 small places. You won't be able to see artifacts cleanly within KubeFlow, things like that. But your question, I think the areas that are specific to Google are the registry right now, which is very easy to point to the Amazon registry. That's just one line change. And secondly, you would change it to S3 instead of GS, for Google Cloud Storage. That has to wait for KubeFlow 0.6, I believe. The S3 support in KubeFlow does not exist, except on master branch. Yeah, hyperparameter tuning, I get this question all the time. I show people Katib, they're kind of a little bit underwhelmed. I like it, Katib, because I actually do kind of like the UI. It's a little bit bare bones, but it's pretty much everything I need to see. Right now, we're just generating YAML by hand, so that's kind of annoying. We've done hyperparameter tuning with MLflow, and really that just entails, we were doing it brute force, but now I think MLflow does support hyperparameter tuning a little bit better. Airflow, we've always just done it brute force. Never really found a good. Okay, so yeah, no experience with Jenkins. Yep, yeah. Just when we train the model. One would normally train the model using Jupyter notebooks, but when running in prod, recommend to turn. Yeah, so I did answer this before. Turning a Pi notebook, Jupyter notebook into a Pi file. There's a couple of different ways to do it. You could do it using something called PaperMill. And NB convert, I think it's called NB, like notebook convert. I don't really have a lot of good experience with, or let me say this differently. I haven't had positive experiences with NB convert. There's always something that doesn't work for some reason. I do like PaperMill. PaperMill is pretty nice. You can pass parameters to a Jupyter notebook, and it seems to work better out of the box. So hopefully that helps. But the best way we've been converting notebook code into like batch files, as you call them, is with fairing. And it's a pretty new project, so there's some rough edges, but that one fairing notebook is the best way we've done it so far. Cool. Terraform. Yeah, single one like Terraform for building. Yeah, I mean, Terraform is good for building any kind of environment other than the features. Something like Google Cloud. MLflow uses Horovod. Oh, interesting. Yeah, so I thought Horovod and hyperparameter tuning were orthogonal, but I could see, like, anyway, yeah, Horovod's pretty nice. How to do A/B testing. So multi-arm bandit, are you talking about if it's online serving, you wouldn't use Airflow for that? Well, you would use Airflow to push out a new model. Let's see. And A/B testing, and I guess if you're doing this offline type of A/B testing, then yeah, you could use Airflow. Parameter tuning out those schedulers. Which needs to load checkpoints from previous top runs. Ah, interesting. Yeah, that's a good point. I don't have a good answer on loading the checkpoints from so obviously you can do whatever you need inside of your hyperparameter tuning run, or your trial, as KubeFlow calls it. so you can, I mean, basically, the hyperparameter tuning part of KubeFlow is literally just a specification to run multiple Python files and collect the output and render it. That's at like the end of the day, not to burst everyone's bubble, that's all KubeFlow is it's a standard way to run some arbitrary Python script, which is packaged into a Docker file, have a standard way to track the inputs, to track the outputs, and to log the outputs, and give you, the human, the ability to choose. Yeah, so right. So Alec is asking, let's see, sidecar. Yeah, online serving for the A/B tests at the, yeah, multi-arm bandit A/B test online, you would want to use something like Istio. That would give you the traffic routing capabilities that you need. And you can, Istio is very much, there's a lot of configuration that goes into Istio, but you can configure it to route traffic based on headers that are coming on the request, or cookies, or whatever you need. Is there a good way to download modified Jupyter notebooks? Yeah, so actually we've got about an hour before these instances will die. Within Jupyter Notebook, you can right-click and, let's see, where did it go here? Right-click, or sorry, click on the notebook that you want to download, and you can click on multiples, I think, too. No, okay, just one, and click download. If you want to, this is a trick I learned a couple years ago. I thought it was pretty crafty. You can create a new terminal or create a notebook and zip up or tar up anything you want. The tar file will show up here, and you would click on the tar file and then download that. Terraform, yeah, our setup really is just the user-data.sh, so not really too much involved. Terraform is if we're, I don't know, there's a point at which we switch over to Terraform, and for this workshop, we haven't needed that. It's just a simple user data launch script for the EC2 instance. Seems to be good enough. Okay, is SPO multi-arm bandit? Oh, and so for the multi-arm bandit stuff, you probably want to take a look at Selden. Selden actually supports that stuff pretty well. And I believe they're moving over to Istio. They were adopters of KubeFlow early on and got roped into the world of Ambassador, which we never actually adopted. We went straight to Istio because of those Netflix patterns that we saw. Okay, I think we're good. People are starting to log off. So again, I'll send out the info. So remember, HTTPS, Community Edition, and GitHub repo / KubeFlow TFX workshop. Thanks, guys. Yeah, thanks for all the compliments. Again, this is the first time we ran it, so the timing, wasn't ideal for some of the stuff, but hopefully it was worth your time. It's the most important thing that I can't give back to you. And final link is community. This has all slide share and videos and such. Yeah, thanks, Thomas. Yeah, thanks for sticking around. You had some really good comments and feedback and stuff, so appreciate it. I'm going to join that the Slack channel right now. Sure. Yeah, we'll try to capture up all the useful links. We could even send out the chat, I think, too, which will include all of this. So, all right, guys, these instances will be up for another hour, and hope to see some of you all in person very soon. And thanks, Ansha.
Sure. Have a good night. Thanks, everyone.
Bye, everyone.